Hello. Hello. Hello.
Good morning. Good morning. It is my privilege to welcome you all here. Thank you for coming. We'll start in our traditional Indian way. First, the light, and then we can, with the blessing of the light, we can start our day. We are behind schedule by a few minutes, but I think we should be able to take that. So can I request Professor Chatterjee, Professor Chaudhary, Kumar sir, please come, sir. Please, sir, please. Yeah. Yes, I think the main.
ओंकार बिंदु संयुक्तं नित्यं ध्यायन्ति योगिनः कामदं मोक्षदं चैव ओंकाराय नमो नमः वक्रतुंड महाकाय सूर्यकोटि समप्रभा निर्विघ्नं कुरु मे देवा सर्वकार्येषु सर्वदा ओंकार बिंदु संयुक्तं नित्यं ध्यायन्ति योगिनः कामदं मोक्षदं चैव ओंकाराय नमो नमः
Thank you. May I request Professor Das to come and welcome.
Very good morning to everyone and welcome to AAAT Bangalore for the occasion of ACCS and CDAC Foundation Award 2021. And it is a great pleasure and honor to have our Professor Subhashish Chaudhary here, who's the at present Director of IIT Bombay. Welcome to this occasion as the recipient of the award. And with this honor, more apt for this occasion, his guru, and with whom he first started doing his image processing kind of works, which became world famous, Professor B.N. Chatterjee, who is here, and he did his project with him. And moreover, it was very heartening to know that both of them, Dr. Alok De and Professor Subhashish, was a roommate and same project, same guru, and they stayed together for the 11 years in their studies life, plus the same corridor of the hostel and the same roof. Dr. De, welcome to here, who was a global VP and all. and also Professor S. Sadagopan, our former director and loved by all of us. He's also here. Professor Khincha, respected Professor Khincha, and he's also very much loved by all of us, and he's also here. Dr. Ramani, and also here, and also Dr. Kumar Sivarajan, City of Tejas Networks, and also the Mr. Bindu Madhav, Srinidhi, the president of the ACCS, Jalendra, all welcome from the ACCS team, and also from IIIT Bangalore, and all the members of the other dignitaries from in this computing and communication world. So, as you know, this event is a very remarkable because this award has given to who's who of this country who has contributed enormous in their fields of the research in computing and communication broadly. And today also we will go through that process when he will be talking about the present recipient. And also there are multiple talks today by Professor Chaudhary, followed by some eminent researchers in this area. I am requesting all the attendees to please be there to listen to them and in this regard. And over to you with this warm welcome to this campus. Thank you again.
Thank you, sir. Thank you very much. Leave it. Thank you, sir. You made my job very easy, you know, to start the day in such a positive note. So let me now talk about a little bit about ACCS. This is a society started in 2000 with the goal of providing a platform for the community of academicians, industrial people, and also the researchers elsewhere, to exchange ideas and talk about the advancement in two fields of engineering, communications and computing. We are very small. It's run by volunteers like us. We do it out of passion, passion for technology and passion also for giving away this knowledge, disseminating this knowledge to the wider community. We have survived so long, so I think there is something good that we must be doing. 22 years. In terms of aspiration, I think we want to be a body which, in the process of providing this platform, we also want to possibly help the governance and the society in terms of advice or our counsel in how to get there, how to bring the country to that level. So if today people feel pride, I must be not to be naming in a different way, but if I'm very proud of being a member of fellow of IEEE, I want people to be proud of becoming a fellow or member of ACCS as well. A long way to go, but I think these small steps will lead us one day there too. Currently, we have a set of activities that we do. Annual conference of ADCOM, Advanced Computing and Communication Conference, flagship event for us. 2020 is 1 year which we could not do because of pandemic. ADC, which is ACCS design challenge for the students, rather less privileged students who don't have opportunity to do projects, etc. at their colleges. We provide them mentorship, the kits and the topics, etc. So they engage in a constructive project work. We are in the process of building an open access library platform, OPAL, will soon go live. We have this award going from 2004 onwards. Last year again we missed because of pandemic. 2020 we missed about because of pandemic. And we also have a magazine, ACC, published quarterly in PDF form. We do not print and circulate, but we do in PDF. So this award is our way of recognizing the people who have made difference to this field. There's no boundary about the geography or the affiliations. All we are saying is that it should be the work which is done. It is the work which is done to advance the body of knowledge in computing and communications. So people from US universities people, non-Indians, Indians, all have received in past, very illustrious people. Some names if I take and others don't, it will not be a good thing to do. It is there on the website, it is in the public domain. This year, we have Professor Swashish Chaudhary as our awardee. Very proud to have you, sir. Dr. Chaudhary has so many firsts in his bio that we'll later learn. I can say that it is also first time that the award has reached IIT Bombay. So, very, very happy moment for us. And you can sense a little bit of bias because I studied there, so I have that home feeling too. I would end here and proceed with the next item. What's that? Give me that, please. Thank you. So may I now invite Dr. Srinidhi to introduce the chief guest, please.
Good morning, everybody. It is my privilege to introduce our chief guest of the day, Professor Biswanath Chatterjee from IIT Kharagpur, whose presence here was a very closely guarded secret for quite some time. And this is a way that we had planned it to surprise Professor Chaudhary to come and meet with his guru and mentor. And I'm very pleased to have everybody here. Professor Chaudhary, Professor Chatterjee was formerly the Dean and Head of the Department of ECE at IIT Kharagpur, who introduced the subject of computer vision and image processing and so many other things for the first time in the country. And the generation of students that he created from the mid-80s to the late 80s still continue. In fact, I should say, besides being the day for Professor Chaudhary to receive his award, this also is a mini reunion of IIT Kharagpur class of 1985. We have quite a few of his students here, and some more are expected in the afternoon. We have Professor Alok Nath Dey, Professor Subhashish himself, and we have Arnab, who is on his way, Subhash Mondal. So quite a few of us are here, and it gives me, again, a great pleasure to have a teacher award his student the award for the year 2021. Thank you very much.
Thank you, sir. Sir, please come. Careful, sir. Yeah, please, please.
So I get the honor to read the citation for the award. Professor Subhashish Chaudhary is a distinguished academician of international repute who pioneered research in computer vision and computational photography. Born March 1963, he earned his B.Tech degree from IIT Kharagpur in 1985, a master's from University of Calgary, Canada in 1987, and a PhD from the University of California, San Diego in 1990, all in electrical engineering. He is the current director of IIT Bombay. Professor Chaudhary's seminal contribution is in developing the technique of reconstituting three-dimensional images using relative defocus between two or more observations. He developed a very elegant solution to the highly posed space-varying deconvolution problem of blur assessment using parametric methods together with joint estimation of two interacting fields such as intensity and depth of a field. Professor Chaudhary augmented his work in computer vision with computational and psychophysical haptics to define the minimum rate encoding required to perceive human touch. Haptic interface has been found very useful in quantifying and studying hand tremors in Parkinson's disease. He developed an automated wearable cardiac monitoring system employing machine learning algorithms that can detect and recognize the type of patient ambulation from noisy motion artifact contaminated ECG data. Professor Chowdhury is instrumental in putting India on the map of international research in computer vision. He's a highly cited author of numerous monograms, books, technical papers, and international patents. He is a fellow of the IEEE, INAE, Indian Academy of Sciences, National Academy of Sciences, and the Alexander von Humboldt Foundation of Germany. He was the J.C. Bose National Fellow in 2008, 2013, and 2018, and won the Professor H.H. Mathur Award for Excellence in Research in Applied Sciences in 2007. He received the Shanti Swarup Bhatnagar Award in Engineering Sciences in 2004, and then the Vikram Sarabhai Research Award in 2001. Most recently, he secured the August Wilhelm Scheer visiting professorship at the Technical University of Munich, Germany in 2019. The Advanced Computing and Communication Society is pleased to confer upon Professor Subhashish Chowdhury, an engineer extraordinaire with the ACCS CDAC Foundation Award for 2021 in recognition of his outstanding contribution to the body of knowledge in electrical sciences.
May I have Professor Chowdhury? Yes, sir, please. Please come. Give it. Come. Aye. That's for you to give, sir. Please, sir. Yeah, you left it here. Sir. Request Professor Chowdhury to say a few words on the acceptance.
Professor Chatterjee, Professor Kincha, Professor Das, Professor Sadgopan, Dr. Aloknath De, my classmate. Sorry, I could not pronounce Dr. Ramani.
Yeah.
And of course, you have our friend here from Tejas. I think we have two friends. I think other person is coming, right? So, first of all, thank you so much for honoring me with this great honor. Of course, I did not think that I will get this, but whenever you get an award, you do feel elated. It makes you feel that, look, when you get such a prestigious honor, okay, then you think back and probably you see that I should have probably done more, okay, which unfortunately I could not do, okay. It happens that, of course, with time you get involved with other activities, not only, even though you are in academics, we are supposed to be always doing, academics, research, teaching, and others. But sometimes there is other part which is the administration, and you get stuck into the administration, and then to some extent it takes away a lot of your energy and others, the time. But nonetheless, I would say that I'm delighted to be honored today, and it's a great honor, particularly to receive it from Professor Chatterjee, our guru, I think, who introduced us, I think, together, myself and Aloknath De together, okay, in this particular area. And normally people start shifting after you go through a long phase of time, but somehow there are people, I think Aloknath has shifted very far off, but I didn't drift in my area. Okay, more or less I stayed into this particular area, and it's also a great honor to see that some of our students here today, they have established also themselves. As an academician, it's our job to create the next generation, you know, so that the process continues, the students benefit, and I hope that particular thing will continue. And once again, before I finish, I think I thank ACCS, Jailendra, for selecting me from out of nowhere, okay, because I think I'm, being the director, now you are a dead meat as an academician, but I think there's still some life left probably there. So thank you for, finding that life in me, okay? So I can say that I'm still doing research, okay? Thank you so much, and it's really a pleasure to be here this morning.
Thank you, sir. Please have a seat, sir. Sir, one thing I don't concur with you, I didn't find, I'm only the medium. The people who have found will soon be on the stage and tell you more about it. I'm very small too. I request Professor Chatterjee to say a few words about Professor Chaudhary. You can be here, sir. You can sit here. Yeah.
Respected audience, Professor Khincha, Professor Dagopan, Professor Das, Professor Ramani, Dr. Rajamani, Dr. Aloknath De, Dr. Jailendra Singh, and my dear, very, very dear student, Professor Subhasis Chaudhary, other eminent personalities in this gathering, and dear students and other staffs of this institute. It is a great honor for me to be here in this chair today of this great institution and of this great society, and to say a few words on this occasion. In fact, I was extremely happy to know that one of my very beloved as well as very too much academic student, sincere student, Dr. Subhasis Chaudhary, has got this award today, and that too from my hand. Although the society has given, but I had the honor to give it to Dr. Subhasis Chaudhary. So I am very much thankful to all of you. Many things have been talked about Dr. Subhasis Chaudhary in the citation, but one or two things I must mention. I consider him to be my grand student also, because he worked for his PhD along with one of my students, Dr. Shankar Chatterjee. So that way, he is my grand student also. And another thing I want to tell about him is that whenever I used to teach at IIT Kharagpur, I always used to say that you have to be a very good human being. And he has continued that quality even today. He is an extremely humble and good person. I want to narrate one incident. It was in the year 1998. I was the examiner of one of the early students, Dr. Rajagopalan, PhD Viva. He is now professor of IIT Madras, senior professor, but not. So that day, because I had some health problem. Health problem was due to overeating. Overeating during the lunch as well as in the evening, Mrs. Chaudhary, Sucharita, invited me in their house. So there, she cooked so nice that I ate so much. And what happened in the guest house in the night, I felt sick. I was vomiting. So I had no option. I had to ring him. He immediately rushed, took me to the IIT Bombay hospital, and I was treated because next day morning I had flight to go back to Kharagpur. That time I was at Kharagpur. Not Kolkata, from Kolkata by train or otherwise I went. So he not only he took care to see me up to the airport because I felt nice after the treatment and I could go, but he informed my house and said that don't worry, I am taking care. So he is like that. So he is extremely good human being. That quality I wanted to tell you. Another thing I want to tell that the 1985 batch of IIT Kharagpur whom I taught, because I feel proud that I was their teacher. Many of them have become extremely, I should say, successful in their career, but all of them are good human beings. I was thinking that Arnav will be coming. Arnav is another, he is another such person, another such person. And I must say that a few years back, you have awarded this award to one of that batch student, Parthopatim Chakravarti. He was also my student.
Yes, sir.
So, extremely academically brilliant and extremely good people were there in that batch. And I feel proud that I was one of their teachers. So I think this is the occasion not to hear much from me, but from Dr. Subhashish Chaudhary. So I have not spent much more time in talking, and I want to thank all of you, particularly Dr. Das, Dr. Jailendra Singh, and Dr. Srinidhi, who has given me this opportunity to be here today and to say a few words. Thank you very much.
Thank you, sir. Please be here only, sir. Sir, Professor Chaudhary put me on the spot saying that I found him. So I want to hear this story for the audience from Professor Kincha and Professor Sadgopan, please. Please, sir, both of you, sir, please. Please. Yeah. Mic is here.
Good morning to everybody. I respected Professor Chatterjee sir, Professor Subhashish, Sri Ramani sir, my friend Professor Das and Director, Professor Sadgopan sir, Kumar Shivarajan, Alok De sir, and from CDAC representatives who are here, and the ACCS office bearers. I don't know what to say now after what I heard from Professor Srinidhi sir, Subhashish and Professor Chatterjee sir. I'll try to spend a few minutes only on what comes to my mind at this point of time. But before that, my formal duties that I have to do. And one of them is Obviously, we were 5 in the selection committee for this award. And that was myself and Sadgopan who are here, Sri Ramani sir, Kumar Shivarajan sir, and Alok Kumar De sir. And we were the 5 who were given this onerous task of selection of the candidates of the award, the CDAC ACCS award for the year 2021. And I should do my formal, at least from my personal side, a big thanks, a big thanks and a big word of praise for all these 5, including myself, I should say, the committee members for having that job. And obviously nobody can dispute us on selection of the people, selection of the person. I can tell you for sure, that is for sure. I think that is one thing that I wanted to mention as a formal duty for me. The second thing, the formal duty that I wanted to mention was ACCS, even though consisting of a very small group of professionals running this ACCS society, but I should say the dedication of the people running this ACCS society, continuing to keep the quality and the standards of the requirement of a professional organization is something to be cherished for. And I think they have kept up this award, ACCS CDAC award, to a level which is now one of the most sought after award that has come in the country today. And I think that is one thing to the credit of the ACCS society to have kept up that. And I wish and hope that this will continue to be so in the coming years. I would like to thank all of the ACCS office bearers for this particular thing. The other thing about the ACCS, that the journal that they publish on a completely no-cost basis has also become one of the journals which is liked by most of the engineering colleges in the country. Most of the engineering. I think I would say that class, that particular group of people in the country, they like this journal and they find it very useful for the faculty and the students of those institutions. I think it's been very, very useful journal. And I think the next venture that they are doing about the library creation and the availability of literature for these people in the profession will be again a very important step in trying to improve the quality of the educations in these institutions. Congratulations and best wishes. And the last part of formality that I should do is also to CDAC. I think that I should do formally, definitely, for having sustained and be a part of this award from the very initiation of this award and continue to support this particular award up to this point of time. And I wish and hope that they will continue. I know that the time that was 10 years in the beginning when we started this award, when this award was started, is almost coming to an end. But I'm sure that CDAC will not let go the opportunity to have the name of one of the most prestigious award in the country in this particular area. And I hope they will continue. But all the best that you have done for sustaining this award up to this point of time. So my formality of trying to remember the people who have been instrumental in this award and instrumental in selection of the individual for 2021 for this award is now done. And I will take 3 or 4 more minutes to talk something that comes to my mind at this point of time. Obviously, when I was Triple IT last month for another award function, and I had mentioned something about the selection process and the thoughts that go through the jury members who are there to select this award, and what thoughts go on in the minds of these people to select these persons. And at that time I had mentioned that there are 2 processes that I have been involved in that. One is the search process for the award, and the other award process is that we call for applications from candidates or nominations by candidates and then select the process. So this award comes under the second category, when we call for nominations as well as a call for individuals giving their details and things like that. And in this process, we see both a quantitative and a qualitative that assessment is wrong. A qualitative and quantitative judgment process that goes on in the minds of the jury to be able to select the most deserving and the most, the person who will be most apt for that particular award. The quantitative process becomes easier, but the qualitative process, I think, is the tougher part of it, And some of the thoughts that come to my mind, I had mentioned some in the search process in the last time when I talked over here for a few minutes. And today in this process, some other thoughts came to my mind, and I thought I will take 1 or 2 minutes of your time to talk about that, of what the process comes to. Now, when we are doing this individual selection, as Professor Subhashish mentioned about the academic responsibilities and now the administrative responsibilities, not now, but I think from a long time. I've seen him when he was the dean and he continued as the dean, deputy director, and then the director now. So he has been involved in the academic processes and the administrative processes in the IIT Bombay system for quite some time. And I think in all these activities of academic as well as the administration, as we call in a quote unquote, the word administrative, whatever that we may call, I think it is the question of the individual's strength in trying to keep what we may call as alternative paradigms in the mind and still being able to take the right decisions, And these alternative paradigms can be sometimes completely opposite paradigms, or sometimes the issues of and, not the issues of are, the issues of are. The issues of R in the education sector could be the paradigms of quantity, quality, cost, price, public, private, and this type of paradigms that we have to deal, whatever that we may do. I have to deal with quality and quality. I have to deal with cost and this. I have to deal with the excellence versus the equity requirements and things like that. I have to deal with these things. And these are the R's of the situation. These are two extremes. But there are quite a few ands which also come in our mind when we do our activities. And I noted on a few of these ands that came to my mind when I was driving through here. So I will read 1 or 2 of these ands that come in the lives of individuals and in the lives of organizations, where we have to exist with both and make the right choices at that point of time. And some of these things, just one. One is to be disciplined and to be creative at the same time. I think this is one of the and position, which is a position which is very difficult to do. To be doing the empirical validation and also to be bold at the same time. To be prudent and to also have big, audacious ideas. And how do I take both these things together? I will be audacious and I will be having big ideas to be talking about. To be what we call as courageous or to be paranoid in doing our work. To be ambitious but not egoistic. To be able to have no excuses and not to be able to hold back also. To be what we call as a futuristic person, but to be also thinking as an engineering sense that I will not predict anything. And to have disciplined thought versus decisive actions. And I think I wrote a few more, but I will not talk. But the point that I was trying to make is that in any career of any individual, whether it is in the social field, industrial field, academic field, or for any organization, I think this type of and thoughts that remain, which the right intellectual decisions taken for these end thoughts make the end result what we see at the end of it. And we see that these end thoughts must have gone through Professor Subhashish's career also, from the student days, of the PhD days, up to now the administrative times. And the right calls that make the individual and the organization where they work to very much better, greater heights than what we can see today. And thank you very much for taking all those right slope directions, the decisions all through your career to have come to this and to be a most deserving awardee for the CDAC Foundation Award. Thank you very much.
Professor Sargopal.
Oh, thank you. I don't really have to say anything because Professor Kincha had summarized the jury process, but because the organizers asked me, so I'll speak a couple of words. So of course, Professor Chatterjee, Professor Subhashish Chaudhary, Professor Kincha, Professor Das, Professor Ramani, Kumar, and of course all our friends. Oh, I think today is very special, Professor Subhashish Chaudhary, because about half a dozen times we call it IITB at IIITB. Okay? Professor Pathak was there a couple of times. Professor Kriti Ramamurthan was there a couple of times. We were actually expecting you last July 4th because you were the chief guest for the convocation, but it had to be done in virtual mode. So finally, today is IITB at IIITB. Thank you. Let me also kind of confess and apologize. So, we came much later than IITB, but in our domain name, we added another I. So sometimes people kind of make a mistake, and instead of sending it to the director at IIITB, the mail goes to IITB director. And luckily it has not been too often, but at least a couple of times it has happened. My apologies to you and your predecessors. Others also happened. So, okay. But I will kind of, because the organizers insisted, I thought I will just tell a story and stop. See, during this jury process, my office always has been an open office, so students keep popping in. So one of the students, I said, look, I am doing this, just wait for another few more minutes. And then after the phone call was over, he asked me, what is your problem? And how did you solve it? I said, the problem is simple, that we had some very, very good nominations, and it was a tough call. And then he said, how did you solve? I said, look, this is Ramakrishna Paramahamsa's parable. So Ramakrishna Paramahamsa once went to some place, sir, you were talking about. So he also overate. And when he was getting up, so he had to be helped to get up. And then somebody asked him, how about little more? He said, no, I am really full. I am full up to the neck, etc. And then he walked a few steps, and then somebody offered sandesh. He comfortably took it and gulped it. And there was a little fellow who was actually watching him all through. He said, how come you said you were so full, but how did the sandesh you could take? Then Ramakrishna Paramahamsa looked at this boy and he said, look, I will tell another story. There was a big event and there were thousands and thousands of people were assembled. And so everybody was waiting for the chief guest. One Maharaja king was there, and then the king came and people are wondering, how will he find time? How will he enter? But as soon as the Maharaja came, people gave way. And then Maharaja could happily enter. So he said, Sandesh is like a Maharaja. So when he comes, everything finds a place. So it could get in. So the point is, as long as Professor Subhashish Chaudhary's nomination came, we were kind of thinking what to do. But once his nomination came, he was a Maharaja. He walked through. And that is how our jury process ended. This is how I summarized it to the student. So I thought that I would share this with you. So thank you so much.
Thank you, sir. Thank you, sir. So Sindhu, let's... Thank you very much for coming here, sir. It was very nice of you.
Great honor. Thank you.
Welcome, sir. Yes. Always pleasure to felicitate you, sir. And both the side. Always pleasure, sir. Always pleasure. That's for you. Please wait for a minute, sir. We'll felicitate all of them and have a group picture then before dispersing. Yeah. So, hey, ACCS is a voluntary organization. Please volunteer. Dr. Srinidhi, please come. And may I request Professor Dr. Ramni to come forward, please?
Okay. So just watch out.
First will test. One second. Dr. Srinidhi, let us facilitate and then take the picture. Dr. Ramni. Dr. Ramni.
Thank you.
PVG, please come. Dr. Day. Dr. Astagi. Dr. Kumar. Yeah. Please come. In the corner there. Now let us see the talent of our photographer. Can you get in one frame? Yeah. Should I think lamp is a good thing. Yeah. Please. Can you get in one frame?
We can get closer.
Thank you.
Thank you.
Please have a seat, sir. I'll have it. I'll keep it for you.
Thank you.
Certainly, Packard. Please have a seat, sir.
I may not be knowing now.
Nowadays I got this, so I remind this year.
Please sit, sir. We'll break in 5 minutes. Please have a seat, sir. We'll break in 5 minutes. Yeah. Please.
And now another photo by Samsung. They will go also.
So Samsung will give everybody a camera. Looks like.
Only Subhash is missing.
Thank you.
Now I will request, please have a seat, sir. I'll request the EC members of ACCS to come forward, please. All the EC members of it, and Binduja, please. Please come, please come. Aye. Ajay. Sir, this is the only reward we get out of. Aye, sir. हाँ.
Okay, maybe we should move this to the side.
अब हो गया. Dr. Ustagi, you don't go away, please. Take to the podium. Here is the mic. Oh, है. Another 2-3 minutes. Please sit. Here, sir.
It's okay, it's okay. Okay, okay, fine. Okay.
No. I said 2 more minutes.
Yeah.
Go on, sir.
Dear all, a very good morning to you. We are coming to a close of this award ceremony. I, Ram Rustagi, is extremely privileged and honored to be given the opportunity to present vote of thanks. First of all, I would say it is a great day for ACCS to continue this ACCS Foundation Award along with CDAC. And I'm honored to have Professor Chatterjee being Guru of Professor Chaudhary conferring this award. Thank you, Professor Chaudhary, very much for being here. Professor Chaudhary, I'm delighted to know that you are the one who brought vision to the our research to the international map. Thank you very much for doing the work. I'm also looking forward to your lecture in the next session so that we can all understand, disseminate, and you'll inspire us, all researchers, to do better and contribute to society and the country. Thank you again, sir. Professor Das, thank you very much for supporting us and enabling us, being the host for us. Thank you again for conducting us in this event. I'll give my thanks to the jury, Professor Sadgopan, Professor Khicha, Professor Ramni, Dr. Sivarajan, Dr. Alok Nath De, for choosing the right person for this award. Thank you all very much, sir. Dr. Srinidhi, who has been the former president of ACCS, who is also convener of the committee. And I see him bring a lot of initiative to this under ACCS, doing the ADC challenge, carrying on this journal, Open Launch Journal, and I call him the leading lighthouse of ACCS. Thank you, Dr. Srinidhi.
The brave.
Sri Jalendra, being the president of society, will constantly be guided by you, nurtured by you, and will continue to do well. Thank you again. Professor Bindu Madhwa, representing CDAC, and being part of this journey to be award. Thank you again very much, sir. This event can't happen without our support, without our volunteers, admin, Ms. Sindhu, thank you. Triple IT being the host, thank you again. And this event becomes successful with our partners. We have our education partners, which is Linktex, which is the education partner, our media streaming partner, Nobly, which is streaming it lively. Thank you again. And at the last, all the audiences, which I said knowledge-seeking, hungry audience for knowledge. Without you, this event can't even exist. So thank you all. Once again, I thank all of you. Thank you.
Thank you, sir. So this is you heard ACCS so far, and we have Dr. Bindu Madhav from CDAC, and you are equal partner in this event. Please say a few words.
Good morning. So I'm happy to be a part of this particular thing because I wear both the hats. I was ACCS earlier, also a member now, and I represent CDAC. I think initially Srinidhi told me to sort of tell a few words about this award. It is too late, but nevertheless I would like to mention a transformation from the Transputer Association or a special interest group which was converted to Advanced Computing Society, ACCS. And a C was added, communication. So that's what in 2000, what it became ACCS. As far as this award is concerned, it's the outcome of an international conference which was held in 2000, HPC, an IEEE international conference on high performance computing. The surplus generated out of this was pooled in because it was a joint conference between ACCS and CDAC. So that whatever surplus was there, we were able to pool in and make this as a proceed, which the interest portion was supposed to be the cash which was supposed to be taken for this award. I'm happy that this series has been continuing. Professor Kincha, anyway, on behalf of CDAC, he has committed saying that CDAC will continue. I think there will not be any change in this stance. Once Professor Kincha has mentioned, I think we'll take it up with the management and we'll continue to support this particular award. Thank you.
Thank you. Thank you. So we will now break. Tea, coffee, snacks are served here, right here. Let's have a quick break, and then we'll come back to listen to Dr. Professor Chaudhary's foundation lecture. Thank you.
ওকে তুই এলে আসিস তাহলে হ্যাঁ ওকে পরে দেখা হবে আরে না আমি ওটা কোনো করবো না ওই নো মানে টেকনিক্যাল কিছু নাই ওকে ও হি কেম অনলি ফর দিস Come.
Srinidhi does a good job. The citation and all, he himself writes.
Shall we start with the
Important, right? Certain things should not be outsourced. Okay, your slides are loaded and all?
Yeah.
Okay.
Shall we
Thanks,
start with the
Surya.
next session, please?
This is something which you should keep always you. Single-handed, because there's a consistency.
Now we have the opportunity to listen to Professor Swasish Chaudhary on what constitutes features in pattern recognition problem. This is the foundation lecture that we are looking forward to. Professor Chaudhary, please.
It is there. And I think I need that. This one. And sometime it creates problem. I can leave it here. Good morning. Thank you for joining. I was telling Professor Gopan that I think by giving me this award, he forced me to come to this because last time I could not come here. So this is okay. So and I start my lecture by showing my great respect to Professor Chatterjee because under his tutelage, I had the privilege to learn, and at least the beginning was there. So thank you so much. And also, since it could be, generally a mixed audience, so I'll try to keep it as, I would say, equation neutral as possible. So I'll not go into anything on the, it'll be more on the top level view of what's happening. And particularly, starting from the good old days, the classical thing, to what we are now, okay? And the purpose of this talk is not to give you a solution, but to give you more of a thinking that where we are stuck and what it is required in terms of the analysis that should be carried forward, okay? So the title that we called it is what constitutes features in pattern recognition problems. So pattern recognition, we know that, you have certain things. We have like one example, so many people. Would you like to recognize person? Or if you want to say that, okay, this is one which is all human beings, but then there could be birds, there could be something else, okay? So whatever is your definition of what is the identity of the class, so you wanted to find that one. So this has been a classical problem even, before even computer science or other people started, even biologists, others, they did it for many years, okay? Because this is one of the most fundamental thing. And even as a kid, you grow with that particular thing. First thing is that you want to learn what this is some X, this is Y. So it's very inherent in terms of our human, evolution, or even in terms of the growing up process. So let's look at that in a little bit more careful thing. So what's the overall building block? So I tried to merge in one picture both the classical one as well as what is currently going on. So if you look at this, so since it's a digital screen, your laser pointer will not work. Okay. It works? No, I think. Huh? It'll not work because it's a digital. Okay, so it'll not work. So if you look at below, this is something what we call the features. So certain things It could be our height, it could be the length of our nose, it could be, like what's the color of your skin, okay? Whatever the things that you think relevant for that particular job. It works now? No. The pointer will not work. So that's what I'm saying, pointer. Other thing works. So there is some data which is given, okay? On the other hand, we have some computing engine which has been always there. If you tell what is to compute, it will compute that, okay? And then on the right-hand side, if you have it, then this is typically what we call the classifier problem, is that you will have some kind of training, okay? So some level, certain things, this is human being, this is monkey, this is something. So something is given, okay, based on which you learn, okay? There are also certain things called unsupervised learning, so we'll not go into this right now, okay? And of course, if you look at in the middle level, which is the blue, so earlier days, if you look at it, we call the way to do this kind of training, okay, through this computing, is in terms of the algorithm, like what kind of algorithm you're using. Nowadays, it's, if you look at the neural network, all this machine learning perspective, sometimes we don't talk about learning, the algorithm, we simply say it's an architecture and something like this. What is the network architecture? Okay, what are then you may have memory relation, something that whether the past is remembered, what is this incremental learning, all those things are there, okay? So this is the overall framework, and we would like to see, particularly in this focus, would be what are the features aspect, okay? But when you talk about the features, it cannot be without the task being involved. So finally, it will be the pattern recognition task. Now, if you look at a machine learning, which is we do today, okay? If you have a black box, okay? Because sometimes we have no idea what's inside, because finally you have some training data. Since it's a pattern recognition problem, we are putting on the right-hand side, it's the classification that we want to do. We want to classify. And during that time, that f of theta, what by that black box, is some network architecture. You have put some whatever, series of layers or of these hidden layers. You have many things that you talk about. And our job is by showing some training data, learn this theta, okay, which is the parameters, okay? And the way to do it is that you have, what happened? Okay. Can you check? Okay. So the way to do it is that you put in some kind of a cost function, which is earlier we used to call this as a cost function, some kind of optimization, something you do, you try to estimate those. So it's but nowadays they don't call it this, they call it more as a loss function, okay? But it's pretty much the same. Now, given the current way of doing it, things have moved so far that almost anything, I think you show it as a, like a slideshow, no, but it's like a one, don't do it, or like, display, you put it as a external display or something, then it will come, so you'll not get into that, okay? You move the display to the next one. Yeah, okay? So right now, the way where we stand, there has been tremendous advancement in the last, maybe I would say 10, 20 years, in terms of how to minimize this cost function. This is optimization field has really done very well, and almost any kind of cost function you define, okay, they can be, they claim that it can be minimized. And the choice of L, that is what is the learning and the network architecture is important. You decide what is the appropriate one at the time of learning. So that decides, in the classical form, what is the algorithm, okay, the k-means algorithm, whether you want to do some Mahalanobis classifier, simple Euclidean, all these things belong to that. Now, the question that we now put it, given this particular one, and since we have been working mostly on the image processing, so I'll just try to restrict, but the domain to be mostly on the image processing side, but it doesn't have to be because many things can translate into other data stream also, is that when we train, so let's say, you have on the left-hand side, you have the training data. Now, what is this data? Do we feed in the image directly? Okay. And if you have gone through the previous generation of analysis, then you would say that normally we don't do it. Even if you do 1D signal processing, you don't feed in the time series directly. It doesn't work. So you try to do something, certain parameters you extract, whether it's some kind of, let's say, autoregressive coefficients, many other things people try to do it. So you don't do normally the full image, but you can have some other things derived from the image. So basically some function of the image is what you try to give it. So the question is, what is that function of the image that you should feed in? So that's basically the focus of this particular talk, okay? Now, when you look at this, so let me put it like, when you define this particular thing, let me go back to the classical thing from Mahabharata, that when Dronacharya was teaching all the students, Professor B.N. Chatterjee was teaching all of us, let's say, this is what it is that you should do. And when they were asked, this is the object you need to recognize before you shoot your arrow, okay, that what are you seeing, okay? Then, of course, if you look at other Pandavas or Duryodhanas and all, they are Kauravas, they were seeing many things. Somebody may be even watching what's happening in the hut, whether it's cooking rasam or idli or something else. But the person, Arjuna says, okay, I just see the eyes, or maybe the bird. That may be like exaggeration, but we may say that I'm looking at the bird because that should be my focus. That's what I want to hit, right? So that's my target. So you try to see what you want to see. That's basically the job, okay? Now, if that happens, then the question is that when we look at it, visually we look at it, we try to focus, we have accommodation, we move this thing, and we know that what we want to do. The question is that in an automation, what would be that process? How do I know that what is to be actually done? Then it has to be mapped into my system that this is the part of the thing that I'm looking, right? So that's what the purpose of this. Now, let's go back to something like more than 60 years, okay? If you look at the classical work of Hubel and Wiesel, okay, which is, I think, they got Nobel Prize long time ago, okay? And what they did is that they showed a lot of pictures, okay, to, basically the primates and say that what do you see, and then they're looking at what is happening in the visual cortex, because that's where every map happens. And this is where you see the brain, that is where you are doing. And surprisingly, they found that it fires up a specific set of cells which are oriented. And they concluded that actually you find out the edges in the picture which is oriented along different directions. So it's like a matched filter in communication if you want to talk about, but they are oriented along specific directions. So depending the selectivity, you do that. And based on that, that goes later on to whatever the inside of the brain, and then you try to recognize, okay? So that's your sensing mechanism, that these are the features, because remember, these are the features that you want to do. So if you look at then, so supposing you have this classical, that image, Lena, and you can actually see that normally, I would not be looking at this, but this is my brain would be looking more on the edge map, okay? That these are the ones, and then it automatically tries to recognize that. And if you try to mathematically write, you take the directional derivative, okay? And sometime it could be noisy, there could be other things, some of them could be short. Then you go for like some kind of smoothing around that, which is typically this is what would be like a canny edge detector, those who, like this. And this then, I would normally, in today's parlance, they call it handcrafted features. But maybe these are actually the brain-crafted features, because our brain, they wanted to see that kind of thing because that's easy for them to understand, right? Now, let's look at this with our current day, what you do. So what you have, the same block that we had before, but if you look at the blue block that we have put in there, is basically that, if you go back to the previous one there, see this particular one, we are saying that the feature space now is CXY, so that's what you see. Now, here what we do is that we don't know what is the features in the machine learning parlance because we don't know what it is there. So you put in this training data as the image itself, okay? And you define a set of, if you look at CNN, convolutional features that you try to do it, you set up a series of them and you put it inside the optimizer. And then you try to learn it so that the idea is that it should not be just C, which is like some brain does it or something that you put it. Actually let the machine figure out what is the right setup, those features, C. So you may call it like C hat or something like this. So they call it end-to-end training, so, okay? And what would happen, C, that you get at the end of this, would be the corresponding, the optimal set of features in that sense for them, right? Based on the given cost function. So no more handcrafted data. And if it is a convolution, something like that, there is no translation, there related problem. They could be shifted somewhere. But the key issue that I'll come back later is that whenever, which is actually neglected by most people in any machine learning thing, they simply don't talk about it because when you talk about recognition, shifting an object a little bit here and there doesn't matter because it's the same object you find out. But if you do it as a regression problem and you wanted to find out what is the angle that you are looking at it or depth, then the shifting does matter. Okay, I'll show you with an example later. But okay, but most of the people, they neglect. Now, let's look at this feature again. Let's say supposing like this. Here is a case that if you have a fingerprint nowadays on the biometric, like look at this, Aadhaar has made it popular, everybody's fingerprint is there. But when you have an attendance system and others, what you can do is that you expect that fingerprint to be, matching and all, and there it's very good accuracy, they get all of them. But I can very easily get some kind of gelatin prepared and, either like a mask, and I can do it and say I can every day come to Professor Das's office by going through that, even though he doesn't even know, because it's very easily I can actually use the spoof. Okay, and it has happened many places, the teacher finds that there is nobody in the classroom, but the attendance is full because somebody comes up, or everybody, I change my thing, I put the next one and next one like this, okay. So this is called a spoof problem. And if you look at the corresponding two fingerprints, okay, they look almost identical, okay. But it's interesting that by doing this kind of process, machine learning, even though we are not manually able to see the difference, but the machine can find out, okay? And this is something that, the deep fraud net that says that I can actually find out if it is alive or not, and then accordingly, so if it is fraud, don't even bother to do the authentication because this is a fraud anyway, right? Kick it out, okay? But then I give you the opposite of that. So that means now the reason for putting it is that there is certain set of features which we are not able to perceive, okay? My brain fails, but machine has picked up, okay? On the other hand, if I go to the next one, then this is like a captcha is a very common thing that you try to do, okay? And the idea is that you don't want computer to learn it, right? So that the humans should be able to do it. And here is an example, like let's say I try to find out, say this one is the left one is an example where human can do it, but the claim is that the machine doesn't learn. Of course, you have not learned it specifically for this type of thing, but in most cases, if you don't learn it like this, you are not allowed. So that means your robot fails to get into the system or automatic, whatever the kind of crawling that you do. But I've also seen that this one on the right-hand side, I have no idea. I don't think, they said this is also a captcha. Even I can't figure out what is this, what does it mean, okay? They said then, below if you can read, it says if you can't figure out, you use audio capture because somebody is then, saying the audio. So the right one, I don't think the machine knows, the human knows. Okay, so what is the feature? I have no idea. But in this particular case, so whatever the feature that you extract, the human is very good in extracting, but not the other way. Okay? So let's go to the next one then. Go to the very classical features which are handcrafted. And let's say earlier days we could say that histogram, basically is just a distribution. It's very easy. It's permutation in, invariant. So basically the image does not look like this. I can do random permutation, it will be still the same. Okay? Then there are different kind of moments. Okay? There is an advantage for earlier bean picking problems and all. This used to be very common because they are like, invariant to rotation, translations, all you can do. So basically you try to do some invariance. You can do perspective invariance because in 3D, so even that's possible, cross ratio. Then you can have spatial or spectral thing, so the Gabor data. These are all classical. Histogram of gradients, LBP, many people have used, and they are all very popular. Co-occurrence metrics, texture models, eigenshape, because where you embed some kind of knowledge. These are all classical methods, and all of them have found use, okay, earlier days, definitely. Now, if you use this, then the next question that automatically you ask, what's the dimensionality of the features, okay? Because I have to, I am creating these features. What is the kind of appropriate dimension that I should have? What is the size of the feature set, okay? Then of course, if the smaller the dimension, it's easier to do it, handle it, may it memory, may it computation, whatever, and if the claim is that they are, robust to noise, but may end up being less discriminative because you might have lost certain kind of information. And you can use some technique, PCA, others, whatever kind of things you are very. But on the other hand, sometimes there is also tendency to enhance the feature space, like particularly in machine learning and others, you say, okay, let's make the dimension as high as possible, okay? Memory is not a problem, computation is not a problem, do it. We used to talk about curse of dimensionality and all kind of thing, but sometimes they say that it's a better discriminability. So you find out the better classifier, seeing that which particular way it can actually classify. And the key problem that I'll spend a little bit of time is that when you have the dimensionality is too high, now the question is that I have to learn that also, right? Whether it's a classical supervised or today's thing, then how many training data set you need? You may not have that much of thing. And I'll tell you one example where we have very few training data. So in that case, it corresponds to a problem called a small sample size problem, okay? So how to handle that? So take an example. Let's say, the person re-identification problem. So what happens that, let's say you have 2-3 gets of IIIT here, okay? And somebody comes in from get 1, maybe goes out from get 2 or get 3, and you wanted to find out whether the same person has gone out or not, or whether somebody is inside. I don't want to recognize, that's a different task. If you want, that's a different task. But I simply wanted to see whether these two people are same, they are at different camera, they may be at different time, one may be day, one in the evening. All these things could happen. There is a lot of variability in the features, okay? So you have to say, like, the person on the query, does it belong to all other people who has, like, let's say in last 1 hour, we ever have gone through. So that's the problem. And in order to solve, if you look at certain literature here, what they do, they try to do a lot of things, like you take horizontal strip, and within that you find a lot of different types of histograms and all. And even though the original image is something like, I would say 60 by 100, or, typically the data. So it's around 6,000, 7,000 pixels, okay? But they create a dimension. If you look at this, is around, using this is around 3,000, okay? So it's pretty large. So that means I should have at least that many number of samples to train. But normally, the training that you can do only hardly 4, 5, 6 data points that you can do for each one of them. And you have to train for one group, and you have to train the other one. Because see, I cannot train with you as you are coming in. So I'll be training with rest of the data, and then new people come in, then I have to do that corresponding matching, okay? So then there is another group of people. There is something called LOMO features. What it is, let's not get into that, okay? So it does a lot of basically over processing. And look at the dimension, it's around 27,000, okay? Whereas actual number of pixel itself is like, only few thousand, okay? So it's a huge dimension. Another thing which is popular is called GOG feature, Gaussian of Gaussian, okay? This is also like almost 30,000 features, okay? Now if you do it, so I have to learn the classifier on this dimensional, high dimensional space, but the number of training samples would be hardly few, 5, 6, not more than that, okay? So this is a small sample size problem. So how do you do that? So one of the things that people try to do is that something called null Foley-Samuel transform. This is a very classical linear, domain problem. So there's no nonlinearity here. So what you do is that, it's basically a classical Fisher discriminant method. So you have at the below, which is like the within class variance, that on the top you have the between class variance, and you want to maximize. This is the problem, okay? So there is a trivial to say that if I can make the thing 0, or the corresponding denominator, then it's maximized provided the top one is positive, okay? And if it is a variance, normally if it is a covariance, it will be at least, it can be 0, it cannot be negative. So you are guaranteed to have this one. So what it does, that if you try to solve it, so basically you're finding a linear subspace, okay, where you are projecting these points, right? And supposing it's a C class problem, C means how many people that you are coming in our case. So it's much fewer, okay, maybe or 500 or 1,000, whatever, but the training sample for each of them, it may be very few. Interestingly, what it does, that this method, all these points in this C-dimensional space, they map into a single point, okay? So if you put it a single point, that SW, then the corresponding the covariance, if you look at that, in that case, it becomes then it's 0, the denominator, right? So that's the key idea. And if you try to do this one, then I can probably show it in a little case. Like you have so many different types of things, and during the learning process, when you do the training data, each class maps into a single problem data, okay? So that's and you can do it for any type of classes. Problem there is that when you actually, the test data you do it, what matters is actually the numerator, because they get shifted. And then you may end up getting a lot of errors, okay? That's what happens, okay? So there is a way to try to rectify this, but I'm not going into that. But because it's a small sample size problem, what people try to do, okay? The interesting thing happens there is that supposing, you can, because it's a linear space, so for each point in that space, I can have like a hyperplane, left or right, and if I try to do all of them, so you are carving out some kind of actually a convex hull of all these objects that if you try to do, all the points within this convex hull will map into that point, okay? Now imagine that if I have done a wrong point, like supposing there is an overlapping of these points here, right? Supposing you have some points within the convex hull, there is this thing, both of them will merge into one point. That means, the reason I'm putting it is that these two classes cannot be distinguished because they are indistinguishable, they map into the same point, okay? So that's like a limitation. See, what happens is that sometimes we, in the machine learning framework, when we try to do is that we do it and we say that, okay, now you can have nonlinear boundaries and all, which is good. But whether it is actually classifiable or not, that we can do it in the linear domain very easily. So these two classes cannot be discriminated, period. That's it. We can tell you with the certainty, okay? And then the next one is, so that was the advantage of this kind of analysis to show that if the feature, you have to ensure that you have to, that what are the constraints that you must follow before you try to solve this problem, okay? On the other hand, now look at the reverse of the problem. So that was a case where I have number of, we tried to reduce in a C-dimensional space, there's a projection. here what you do is that the kernel-based method, which is another popular method which is over the last around 20 years or 15, 20 years. What you do is that you try to blow up your feature space, okay? And what is the purpose is that I want to still probably want to do a linear classifier, but the kernels could be nonlinear. I project it into some kind of unusual space, create a lot of such extra points, and then I can use some kind of a classifier. Hopefully I may be able to separate them. So this is another thing, and many people that do it. But of course I need, the computationally it becomes a lot more expensive because you are generating that and you have to find out all those things. So sometimes it's a problem, particularly if you have so many classes and others. Now I'll give you an example. Now if you feel that this is a good feature, that we have some idea of the feature, now I give you an example where I have no idea what the feature is, but we are able to solve the problem, okay? So what you do is that we can develop a 1-bit video codec, right? So what you do, or it could be used in hyperspectral data where you have 250 odd bands. So there is like a huge number of bands. It's a data volume. So you can take, let's say, some 8 or 10 such frames, or maybe the corresponding bands. Then you randomly select a set of points, okay, and collapse it into a single snapshot. So it's called coded snaps, the next one in gray. And then next 8 or 16 of them, you can actually have another snapshot. So then, after that, you do 1-bit thing, like if it is greater than some value, take it, otherwise 0. It's basically thresholding, nothing else, okay? You can use some other diffusion process to improve, what you call the half toning, that comes from there. So then it's a 1-bit plane. And since it's 1 bit, but I can use 8 bits, so I can now again squeeze 8 of them, and I can make one frame. So now look at this. You have this orange one, a single one image, but it has the data of all this video stream, okay? And what you do, so if you mathematically write it, some V is your the video volume or the hyperspectral volume. You do some functional mapping phi, and just take the, let's say, sign bit or thresholding, and you have the observation. So if you look at this observation, it's almost, if you see this picture, there's nothing you can make it. It looks like a real random pattern, okay? But I can use some kind of a machine learning technique, saying that decode this, okay, and get that video sequence back, okay? Now, why would I do it? Because if you are, what is the reason for this? Is that if you are flying, let's say nowadays drone, is there satellite, and sometimes you have a battery life is very important because any kind of encoder, decoder that you do on the board, then it needs a lot of computation, battery, as well as transmission, right? If you have to do the ground transmission, if you have to do. So it actually has no encoding in some sense, because there is, see, any encoder will have a decoder in the loop. There is nothing there. So it's absolutely zero computation in terms of that. And then actually what you do, now look at these 3 cases. It's the raw video. Now the question is, can I play this? Can you click on the top one? Okay. So if you can, I don't know whether I can click it here. Or maybe I can do, okay, I think I can do it here. See, this is the raw video. It's a small video segment, if you have played. You see that this is the HEVC, which is one of the state-of-the-art video encoder. Okay, it's commercially available. And this is just 1 bit, okay? And you generate this one. Of course, there is some entropy coding that may take, but if you don't want, you can remove the entropy coding. See, if you play it here, you get very similar thing. It is not much a difference. I could do it from 1 frame, okay? So, and if you plot it, in terms of the performance-wise, it's not too different. We are marginally poorer, okay? But if you look at the savings in terms of compression time, it's significant, okay? And that includes because you have entropy coder. If you remove the entropy coder, we have almost no computation. So in this case, we have no idea what this this basically these features they look like, because manually we cannot even figure out what it is there. Okay? Let's look at another problem. See, in certain cases, I'm not interested in the entire picture, okay? But there is a class of problem called co-segmentation. All I am interested is that if I give you some set of pictures, okay, is there anything common, okay? So get that foreground, which is the common. Now within that, let's say here in this case, you are looking at tiger, normally you would say, but there could be outliers, which is completely different. So it should not come up on that particular one, but it should be able to find out that these are the boundaries, that is what it is. And if you try to do it this one of the simple ways people try to do, first I show unsupervised. So you can use something called superpixel segmentation. You say you have a segmentation map which is fairly uniform in terms of this one. Do some handcrafted data. Typically here I think it's around 256 dimensional data that I think we have. Then you put it there on the find out for the entire all set of images, where do they map in the feature space? So it's like a distribution function. And in the distribution, do you find is there somewhere, if there is a mode in the distribution, then if that mode is there, that means that is the commonality that you are looking at it. So problem turns out to be a very classical statistical problem that find mode for a set of data, which is actually very high dimensional. But mode estimation is very difficult. Okay, let me tell you in that case. And here, if you see that, so forget about the equation, we'll not go into that. Then you can see that I can find out the mode over there, okay, and this is unsupervised. And this would actually translate into what is the point there, okay. So I have an idea in this case that what this feature, they should somewhere be closed, and I can get the data, right? But if you look at on the other side, I would say that, look, can I train it? I don't know, this thing doing it, finding the features, the mode computation is expensive. Actually, it's a very high dimensional space, and it's very sparse, okay? Because how many points can you have in this space? So what you can do, you can have a simple kind of network where you show the image and you train it with defined mask, okay, whenever they're common, and let it learn, okay? And if you say it is the same object, update it, okay? If it is not same object, like this, if they are like different, one case is a cat, other case is a car, you say don't update that, okay? So there is a decision process. So decision net, so I'll not go into the whole thing. So the predicted mask should be null. Now if you do this, now look at this. So left-hand side, you have this unsupervised approach. On the right-hand side, you have a supervised thing, okay? Which is, of course, much better, okay, compared to this. And it's much faster. Training may take time, but actual processing is much faster. So here is another example that if you give all these pictures over there, it figures out what is the common part of it, right? So this is all of them that it can actually do that, okay? Now, the advantage and the disadvantage that we could say that in case of this mode estimation, we had some idea what we are looking at it. But in this particular case, we do not know what is happening, right? So that brings to the next kind of problem that if you have a feature, I think we have probably the best person in machine learning here is, I think, Venkatesh Babu is here, okay? He's an expert in this. Let's say, supposing we have a kind of training that we do in machine learning. It's very common that you train, and nowadays there is also something called semantic information. So you add some semantic information to your learning process, and how does it mean? I mean, so if you say that I have an image of sofa or image of a cat, okay, these are I'm interested in the classifier, and I give some semantic information that this is a sofa, and this is next one, say this is a cat, and it could be in word2vec. There is another very simple thing that is done. It's a very nice idea. It is seen that your accuracy in terms of your classifier improves, okay? And if that is true, then we thought that word to vec is basically somewhere is the vector representation, right? Somewhere you represent. Now, if you follow Shakespeare, what's in a name? I mean, if I don't call a cat, I call it Billy or something, my other thing would be different. But ideally, it should not matter, right? So why not we flip that, okay? So we say, okay, I call sofa as a cat, okay? And this is like this, retrain it, okay? And what you find, then again it improves, right? So actually it doesn't matter what you call it. So what is happening then, right? So this is the question you may say always, as a human being we try to relate them. So he said, no, it doesn't matter, okay? So what is the reason? You have to understand the moral, why is it happening? So let's look at, so what I call it nonsensifying the semantics, because now I've completely changed the, make it a nonsense, like, oh, this is something, this is not even a cat, this is a monkey, okay? Whatever you feel like. So let's say I have a set of data that I wanted to classify, which is quite cluttered, okay? Idea is that in the network, supposing any kind of neural network, that what they do, they try to distribute it in terms of mapping so that they get a little separated. Now, what it does, actually we can call it like in a guide set, like use a prototype. So see, what is this word to vec or the semantic information? I am giving just a vector here. There is another vector here and another vector here. So normally two vectors, why not I try to give a better way of giving this information? Make the vectors as far as possible. If you, instead of making it close, because that's where then they can map it much further. The name doesn't matter, okay? So if I have to do it, so let's choose the, this, where the Hamming distance between all these vectors would be much larger, okay? And just randomly assign something, and that's what we do. So you put 5 of them, let's say in this thing, and see they are separated. And interestingly, your accuracy goes up by around 5 or 10% in different cases, depending on. So then we said, okay, what about the other way, okay? Here. Now, supposing I don't want, but I know you have good features. So I want to borrow it from your features. So what does it mean? So you have solved some problem, where you have done a good job. You could really classify them very well, okay? So instead of, and my data is bad, okay? So instead of mapping with that kind of a vector, I say simply that let's use your data, that particular class data as a guide, and try to map this class to this class to this class to this one. And since they are all separated nicely because you have done a good job, okay, and you are my friend, you are giving me all this value, just let it learn. Then they will separate it out, right? So if you try to do it, now again we see that again this also works quite well and it improves. So that means actually it's not exactly what is the value of this, the prototype or the thing, as what it matters is basically the separation and how you can train. Remember the first assumption that any kind of mapping, I can train it properly. So that's what, as long as you do it, then any feature which is well separable, I should be able to separate it, okay? That's why we call it like a GookNet, okay? There's a guided clustering kind of thing. And what are the, just to give you an example, like when I borrowed feature, so what you wanted to do, that the below one, so these are the different classes of pictures you wanted to separate, okay? And what you use, there are trained classes there, and to guide, you use what is known as the MNIST data. So this is basically 1, 2, 3, 4, all these numbers, okay, written, and it is now today is almost like 100% accurately you can actually classify. So you simply say that this left one, you map it to class 4, the right one, you map it to 7, and try to learn. It turns out that that works better, okay? So if that happens, then people simply say that the CNN features, now this is, remember that series of these in the machine learning, those features CNN are like the right thing because they are all end-to-end class, the trained, so they are the optimal set of features. Now, is it like really the panacea? I told you that this is shift invariant, but there is, whenever you have it, there is an edge shift. Is there a penalty associated with that? So that's what now we wanted to see. So supposing the features that you are using, if there is a relative shift, okay, because depending on the edge, okay, because when you do CNN, there is a, forget about the nonlinearity part, okay. If you use, it's basically kind of a convolution, okay. So convolution means now there would be change in the function. So zero crossings, that means wherever the derivatives are zero, they get shifted, okay. If it shifts, okay, does it have an effect, okay? And this shift would depend either data dependent. I cannot predict before that, it depends on the data. So why not try to do it from the recognition part? As I said, it's not so much of a problem, but we wanted to do this more of a regression. And one of the possible way is that when you want to see something, and it's a 3D object, and I see it from here, next time I wanted to see it from somewhere else. So I want to find out what would be the next view selection. Because if you see from, let's say, this object from here, you would, you do not want to see it something very close because that doesn't add much information. You want to see it a little far up. If it is too far up, again, this is like a human or any other machine problem because they will be very different. Then you will not be able to match them. So that also is exists. So it cannot be just like, you view that 180 degree. So that's also is not the solution. So this is called a next view problem. And here I need to find out where it goes in the next one. So it's a kind of a regression that you try to do. And it turns out that if you try to solve this, so here, don't worry about the network architecture, but if you look at the accuracy. So IOU means what is the overall, the common area that you have over there divided by the actual thing. It's quite low, okay? So even the best possible thing is around 0.6 or something. We are not able to go beyond that, okay? So that means there is an inaccuracy creeping in because of this, okay? So the question is that whenever you have an encoder-decoder problem, my encoding-decoding is working fine, but the regression is not working fine because I have this problem of shifting. Another kind of thing that is so can I have like 5 minutes and then finish? Yeah, okay. So sometimes what happens is that you don't look at a problem as in one entity as itself, but sometimes the entities in the picture that you have in different places, okay, together constitute some notion of what you will do, the pattern that you have. Let's say, for example, if you look at the left one, even as you are more looking at the airport, okay, it's not like a plane, okay. Similarly, there could be other cases like, where it is like next to it's a beach, okay, but not like a desert, okay. So that relates to certain kind of entities. So if you want to do it, you wanted to bring in relationship between all the adjacent areas. So one of the very common way of doing it is that you can use, so let's say what you call GCN, graphical, the corresponding your CNN, graph CNN methods, okay. And it seems to be working fine, but the problem there is that again, people use typically when you have uneven areas, it's a handcrafted picture, your features. But so at every node in the graph, okay, these features I can define, but what is the relationship between neighboring? That I have to learn. So this is what we have to do. And then you can actually find out, yes, let's say certain things are related, but not something very far up may not be related. And this is something is done. And this sometimes there is a problem here because for each picture, those who are in the graph theory and all, there is something called a graph Laplacian for a class of graph, okay, which defines the type of relationship. But here, for every graph, the Laplacian is different, so certain things cannot be done. You have to do it some approximate way up to this thing. So this is where you can say that, the relationship is a edge actually can be estimated. So that's also people try to do that, okay? Now, I end with some thinking process now. Okay, here is some problem which they have been reported. You look at the first job, okay, the person who has done is a very well-known researcher, okay, from MIT. You give a speech sample, okay, and the network actually cooks up, this is how the person looks like, okay. Now, I don't know, I mean, supposing, you know, I've not seen Professor Sadgopan, but I talked to him and, you know, this thing is that I know his voice looks like. Now, can I, you know, actually say this is how Professor Sadgopan looks like? Now, they claim that they have done a good job, okay, but I don't know what is the meaning of that, okay? I mean, this is completely unusual, right, in some sense. Like, maybe tomorrow somebody said this is the DNA of the person, and this is then how he would look like, okay? So if that's the way it's going, I don't know, there is a danger, okay? And then next one, okay? Here you look at, there's a Maharaja Thali or whatever, whoever serves this kind of thing. And the claim is that they can tell you what is the calorie value of that, okay? So that you can budget your thing that this is I should eat or not, right? I don't know what it is because sometimes, you know, how it is done, what is the sanctity of this kind of, you know, work, okay? The third one, okay, is look at, so the person is carrying some weight, okay? And by looking at this, they have trained network and they say, this is the weight the person is carrying, okay? So remember the good old story of the donkey carrying that, you know, the cotton, and the person says, okay, get it wet, okay, and this thing, and then the, you know, that's what happened. They are not able to carry. So whether it's a wet or dry, there is a lot of difference. But what happens in the network, okay? They claim that they are able to do it, but I think from our side, there is some justification from the human side, if you look at it. Because it's the bending of the back, if you look at it, you know, that probably tells us that how heavy the load is, okay? But of course, that depends on the individual, okay? To me, something is very difficult to carry, but maybe somebody who is a bodybuilder, it may not be, okay? So these are the things, I have seen a lot of such work, okay? Personally, I'm really puzzled by this because my idea is that what are the corresponding things that lets you take a decision or some kind of inference that this is what we are looking at it. So I have no answer to that, okay? And because of other problem that we have here is very common, okay, since we are talking about this, is that when you look at the different class of objects and you try to define, okay, in the earlier cases, we used to define boundaries which are nice, maybe it's a linear or maybe, you know, let's say supposing you do some kind of elliptical and others. So we do make errors sometimes, but catastrophic errors were less, okay? But look at this, supposing you put this kind of figures and we are tweaking our boundary, making very close, you know, as you learn, you know, sometimes there could be overfitting. But in the feature space, you do not know who is neighbor to that. Supposing you have small error in the data or maybe, you know, perturbation. Now starting from this, let's say supposing it's a baby, okay, and there is an error, you end up being recognized as a monkey, okay, and that's look very, very different. As a matter of fact, this becomes an ethical problem because it has happened several times, you know, somebody whose, you know, complexion is very different and it turned out to be a monkey or something like this. So it's not that, you know, people try to then bring it as an ethics or something like, you know, whether we should be doing it or not. But I don't think the real problem is that. The problem is that by trying to doing it and mapping, we have no idea what is the manifold of the feature spaces. And if you try to do it sometime, we have no idea that this is like, you know, the very close in the feature space. And suddenly you transgress into something that is very different. But on the other hand, if you look at the two shoes that I have shown there, okay, the pairs, they are actually in between, there is a different class coming in. So you go like this. I mean, this is of course concocted, okay? But you are able to say that you are happy as a classifier and you say, okay, this is the state of the art because I got it recognized. But, you know, since you have no idea what's happening and the feature space is very high, okay, you may make such kind of error, which is really in some sense socially wrong. You know, that's what happens ended up. But I don't think algorithmically there is anything wrong in that, okay. So I'll, you know, probably now close. So to some kind of conclude, I have to finally have a conclusion for which I don't really have any real conclusion, saying that we tried to discuss in terms of how to learn the feature space, what is the, you know, trying to get a meaning for that, what kind of dimensionalities aspect that we touched upon. We also looked at, many people talk about the semantics. So actually, in my opinion, it's not the semantic. It's just like, you know, you have to put them, you know, you need some kind of a guide to just get them separate. And of course, this is more, you know, what oriented edge filter is to visual cortex. That is a classical thing from Google and Weasel. Now, people claim that this is the CNN features is the same to neural network. You know, is it the same or equivalent? We don't know, maybe in future can tell us. So thank you so much, okay?
Thank you, sir. Thank you very much. Very exhilarating talk. We will not have a Q&A now. We are going to have some time for shortly. So, these are your questions for the presentation. Now we are going to have very interesting discussion with Professor Chaudhary, where we want to understand his life, interest, and hobbies. So stand by. Just set up the stage and we'll be back to you in a minute.
that is easier. Okay, so first of all, as a kid, I tried to dabble into tabla, and I thought this would be a good thing to do as a kid. Within first 2 lessons, then I realized it's not for me because it started training my finger, all these things, so I'm out of music. Okay, but what I found interesting is actually reading. Okay, and I think in the earlier years I was like really a voracious reader. Okay, used to read particularly literature, Bengali literature was read. I think almost majority. Yeah. But, IITs those days, nowadays it has changed. When we were kids, particularly, studying Kharagpur, we used to get 2.5 months pure holidays. I think, there was no question of internship, there's no question of anything, there's no mobile, no TV, okay, even TV very less. So, it was like a complete time to go to the library. I was in a small village. We used to go to the library over there and collect all the books and read. Okay, of course, with time, the type of books you read that change. I think the focus change. I remember thing which is more fulfilling in terms of reading. I think that's what I would say that that time was the time where we other felt fulfilling. I think now it's more on Vedantic philosophy and other. But yes, so I would say that time read the mainstream.
Read then. What would be your favorite subject to pick up and read?
It depends, like when you are college going kids and something, then you gradually migrate into something, then I think right now, as I said, is whatever I'm reading is more like Advaitavad and others, getting, like what is the philosophical underpinning, what it means. It's also quite fulfilling in that sense because you get a perspective, different perspective to life, the society, the development. I think that's what we wanted to learn with time.
There used to be this thing around in colleges that you should be reading Zen and the Art of Motorcycle Maintenance, the Tao of Physics, to be there, right? Did you pick up any of those books?
No, actually, see, if you, I don't think we should be always looking at, what helps me today. I think if you do that, I think that your focus is very narrow in that sense, and you are, myopic, I think the right word is used. But if you read something, you do something, leave something that an aftertaste, like, the coffee. Okay. The French way of having it is that they want to kill the aftertaste by immediately after coffee, black coffee, they give you a chocolate. I think I hate that. Okay. So when you do something, when you have, there will be something for future. Okay. And whenever even my reading and all, at the end of when I close this, I think I would always look into that, is that was it worth reading the book? Or it was like, this is something also I also, many times you do. Of course, nowadays I don't get too much of time, I must say that. But this is something that, what is the kind of thing? Okay, it's a nice novel that has something different. But if there is something different, okay, what is the learning? I think that's what says that I don't have to use it now. Maybe 5 years, you never know when it's useful, right? And I think that's the spirit I always try to follow.
Interesting that you are talking about it. Very early in your age, probably you were already getting ready for machine learning.
That I don't know. I mean, those terms were not there.
On the lighter side, if you are saying that what is the learning, so you are already trying to pick up the right data out there. Just on the lighter side there. How
question is that, many times it's true that if you keep focused in one thing, sometimes you can do a lot more things, but human capability also you have to look into that. I should be fully into that teaching part of it, okay? Then you will do that. At the same time, when I am there, I should not be thinking of what I should teach there, okay? So the planning, whenever you have time, you do it. Maybe the night before that, before going to bed, you think about what would be the plan for teaching. Because I must also tell you that when I started teaching, okay, as most of us, you always, start with a note, okay? Nowadays, it's become easier because many people use PPT and others, right? So that's, you have this. And I did it for few years, okay, initially. Then I realized this is not how I should teach, okay? The reason is that, of course, when you have set of notes, others, it gives you a kind of direction. I know that what is the flow. But there is also something from the student side, right? So for example, so I made a point very soon that I should not use any class notes or anything, or even PPT, okay? I should just go and do board work, okay? And if you do the board work, don't use it. Okay, occasionally you may, so what is the next type of, it may happen. But I think that since we are in IIT, we are, quite privileged, a lot of excellent students, okay? So they themselves will say, oh, this should be the next step, or you made a mistake here, okay? That's no problem. But I think then what happens is that you are involved into the proper way of teaching, okay? I think that's what I always followed. I think till then, after that, I said, okay, done with my note. I'll not even save it anywhere, okay? Because when I was giving up, and that one course that I was saying, the next person said, can you give me your class notes? I said, sorry, I don't have anything, okay? So it's all gone, okay? So I think that's what I try to follow.
But that's a very interesting practice, because these days in many of the institutions, you are supposed to submit your notes beforehand.
That's I think that's because of the pandemic is more. But I think in US and others, they demand that Europe, that you have to give them this one. But I think, frankly speaking, being in some of these privileged places, I think, if we do it purely on that, even I've done the other way also. See, sometimes what I've done, like you can do it in a, on the tablet, and at the end of it you can upload. But at the time you don't use it, you just do it on the tablet, on the fly.
See, I can understand as a researcher, you can come up with, if I ask you what are your challenges, you can come up with a million of them. But as an administrator, what is your biggest challenge?
I think, see, the administrator, again, typically it should be one of the, remember that at the end of it, I am also a faculty member, okay? So if I exclude myself that I am only the director, okay, and no longer a faculty member, then that would be the first wrong step that I would take, okay? So each faculty member brings with a lot of their own, their expertise, research. And also, typically the way it happens, a professor normally is like an emperor, okay? So they have their own fiefdom, this is, so handling them should not be like an order or anything, right? That doesn't work, okay? It's like, I've seen some places that do that, particularly even many, countries outside, but it should be more like getting it through the consensus, get them onto the process, and at the same time, you have to follow the same set of rules, right? So if you don't, then there's a problem, okay? So till the deputy director, I used to always say that I will always do a like a lecture. I'll never miss a lecture, okay? Number two, if I am also a researcher, because that's what we demand that you have to do, then I should also have some time for me to do the research, because that's basically a refreshing thing for any of us as a teacher, right? So one of the things I decided that, to see that you have to be one of the faculty members like that, and they should say, okay, yes, the director is also working on this. Of course, now I get much less time than in earlier time. But the key thing is, like, I should, probably still publish, which is little difficult. I have now some collaborators like Biplav and others, they are helping me. But one thing I do is that, can I have during tenure of each of my, let's say, like a head, then you have like a dean, deputy director, and now the director, at least one monograph to show that, which takes a lot more time. So can I have at least one monograph published during the tenure of that particular, program? So far I have done it, and as a director, I have not been able to do it, but I think we should be able to send the thing to Springer in another 5-6 months. Okay, so then I think
That's amazing.
so should be able to do that.
What you are saying is, you are leading by example. And one of the biggest challenges as an administrator, as you rightly said, is managing people. Right? And I found while researching about you that you are a prolific writer. You have published papers and published books. We'll come to that, we'll shortly come to that. I would like to, shift gears here, move a little bit back to your childhood, not school days, high school days perhaps. What is your earliest memory of interaction with science and technology in a serious way that would hold your interest for the rest of your life?
I think the interest is before, see, I come from a probably, I would say one of the poorest districts, okay, in India. It's Murshidabad district, okay. And almost, even now probably there is not much thing, except probably that time the key industry there is bidi, and most of the people were actually those who do the bidi. But the great thing was my father, okay. So he was like what you call the headmaster of the school that I always went through. And he was also helping in terms of, those days, particularly that being the place, there was no place for education for girls. So he used to basically go to what I am doing now as a director, begging money for, alumni and others to set up this. He used to do it in his time to talk to the so-called the rich people over there, okay, give the land or give some money to set up some school for girls and others. So the key thing was that, you would say that do whatever you like, okay, and then particularly science and others, he was not a person of, man from science, so he was more of the humanities side, okay. And what I found was that, anybody used to come, okay, he was a very good, I was a matter of fact as a school builder and all, so many people used to come for help. And my father sometimes, he said, okay, the person has come, I have to do my grocery today. So he says, before you go, you ask him questions, okay? And invariably, the question happened, whoever is the visitor, okay, was in some math, because that is the easy thing to, okay, if the monkey goes to, that problem or something, whatever, ask him some question. So it gave me a little bit of advantage, because almost any visitor to our house has not gone to our outside without posing a question to me, okay? And that actually gave me a lot of confidence, particularly in mathematics, because it happened in the math mostly, right? Because that is easy to do, okay? I mean, nobody asks, okay, when was the first Panipat battle or something? That's very rare, okay? It would be more like solving this math. And then I started enjoying it. So then what happened was that, of course, you move, this place was, only problem was that education was not the focus of that area. Okay, so my father said, okay, you had up to 10th standard, moved to a place, and then what happened was that I was put into Narendrapur Ramakrishna Mission. I think you talked about Ramakrishna Mission. So I was there in Narendrapur. Then suddenly, here is a topper from a school. Suddenly you drop it into this place. And I found I was nowhere. My training, whatever I did, I was doing very, very poorly. Then we, I think initially struggled that, okay, because these are all kids from various other places, okay. And that helped, okay. So it took me like 2 years, and that gave me, I think, enough confidence that when I went to Kharagpur then, okay, then I think it just like, because these friends were there, many of them, then you build up like a kind of a self-help group. And that put me in a good state.
Excellent. You went to IIT Kharagpur. Just before I jump into this question, did you think about getting into IIT, or was it an,
Well, to be honest, my father did not want me to be an engineer. Okay, that's for sure. He wanted me to be a doctor. Okay, as a matter of fact, he wanted everybody to be doctor in the family. Okay, and I remember that I promised to him was that, okay, in the 11th, 12th standard, that I should do biology. I should keep the biology. Okay, so which I did. Then what happened was that in our particular year, somehow some question paper got leaked in the high secondary exam, and then our board exam or the local West Bengal joint entrance got little delayed. Okay, so I think we finished our practical exam plus 12. Next day we are in Kharagpur joining there. I think all of them. Okay, Aloknath was there, in my roommate there. And what happened was that after a month or two, okay, I think that West Bengal, the medical board results are out. Okay, and my father did not like that, okay, I'm in engineering. Okay, so he said, you have to move to medical. Okay, so what I did was that, that there was physical counseling. So I did not go, okay, because I like this thought, I thought, this is the right kind of thing. So my father then, when I did not go there because it was in Kharagpur, I was in Kharagpur, and that was happening in Calcutta. So he met I think, nowadays it's unthinkable because that, nobody has that kind of permission anymore. So he talked to the, whoever was the admission coordinator for the medical area, said that, can you give me like a 1 week time to convince my son that I can bring him back so that, he comes back to med school, okay? And my rank was very high there for some, for some reason. So he said, okay, normally we would not do it because you was like in the top, so okay, I'll give you 7 days, okay? Then those 7 days, I said, sorry, I'm not going, okay? But then my mother came, said, okay, if he wants to do it, okay, why not, why insist, okay? So he agreed. But I tell you the reason why he was insist, I mean, you have to look at from his perspective, okay? He was, when he was 7 years old, 7 or 8 years as a boy, okay, he actually lost part of the eye, okay, because of some fishing, he was doing fishing or something, okay. And as a matter of fact, he was the first cornea grafting person probably in India, okay. Somebody, as a kid, nobody in the village knew it, so he just landed up in Calcutta. He was crying in medical college corridor somewhere, okay. One of the doctors says, okay, boy is crying. He says, he's like very young, maybe had hardly 10, 12-year-old. He says, why are you doing? He says, like, I have problem with this thing. He says, he looked at it, okay, and he says, go back, okay. And the reason he was sent to Calcutta was, this was like last visit where he could see something. After that, probably he will turn blind or something. So he went there, and this doctor says, give me your address. If I call you, you should land up there immediately, okay. So he came back, and immediately he got a letter that somebody's cornea was to be, there. So he went back, and he got this thing done, okay. This is, I'm talking about, I don't know, it must be like before 1950. So because of that, he had an absolute fascination for doctors. He says they can change your life because he himself is a beneficiary of that. So he wanted that in me, Okay, and that's, I think, his justification. So if you look at it, he was not really pushing for no reason at all. I mean, there was a reason for him to do that.
No, definitely, but I think many here, including me, are thanking God that you, took up engineering.
But maybe somebody else would have thanked there.
On the lighter side, Professor. So you went to IIT Kharagpur in 1985 to do your bachelor's. The field was pretty young then, probably from 1965 to 1985, it went a little slow, right? But there were amazing research work being done. Some of them are right here who pioneered that research. But how did you land up in Professor B.N. Chatterjee's class?
Okay, so, when you are in the hostels and all, you you discuss, okay. I think then you look at in the final year, we are the 5 years batch that time, okay, it was little slow pace than now the 4 years of it. And we were thinking what to do, okay. And Professor Chatterjee, he taught us a course on control theory, I think, before that. And I think there was another course on industrial something, heating or something, I forget. Industrial electronics, something like that. I think he taught us 2 courses, okay. Now, what we found was that probably he was the most gentleman person that we actually seen as a teacher, okay. He was extremely fatherly person, okay. And whatever we had problem, okay, that, we told him, he says, don't worry, it will be all fine, we'll see everything. And his personality was very, very, different, okay. So even now is the same.
One thing I forgot in the morning, these people were so friendly, they used to come to my house. I don't know whether Suvasis was there.
No, I was not there probably.
Suvasis was there.
Mike.
In the morning, I forgot to tell that this batch of students are so friendly that they used to come to my house quite frequently. Sometimes they used to tell my wife that you prepare food for 8 of us. We'll come in the evening and we'll eat it. I don't know whether Suvasis was there or not. Maybe not, but some of them were there. And they used to finish everything, and at the end they said, only this much. We wanted much more than this. So they were very friendly, not only with me, with my family also. Okay.
See, also what happened was that it's not also, one is a personality, and the second thing was the area that time was coming up, okay. We did something in those days, you had to physically go to the library. We looked at, it looks like it's an interesting area that you can think of. Of course, we did not know much before you jump into that. So then we started, but I think I must tell you also, unfortunately we picked up a very difficult problem, okay. We realized, myself and all of that, we are not really able to make out what it is. I think today if you say that we are too young that time, it was a statistical, I think texture analysis, I think in some sense stochastic modeling and all. So we did not have a proper training that time. So we used to go and say, sir, we are not understanding anything, okay. Then he used to tell us, okay, try to do it. If you can't do it, don't worry. So hindsight, I would say that probably we did not do a good job, could not do rather, I would say, any good job in the thesis at all compared to what current set of students do, okay. Because but that way what happened is that once you face a tough problem, then you realize that there are nice, interesting problem, you should be able to take it up.
Very true. Very well said, Professor. You went to University of Calgary for your master's in electrical engineering, and then University of San Diego, where you earned
University of California at San Diego.
University of California at San Diego, where you earned your PhD. Your area of interest were pattern recognition, image processing, and computer vision. One leads to the other. What made you pick up this area? Was it your training in Kharagpur, or you had
I think since we started working, we could see that there are a lot of interesting things happening. But I must also tell you, this is just before the medical imaging coming up very strongly, okay. So we realized that at some point that it's an upcoming area, okay. There are certain nice things that you can do, but not possibly in the form of, we did not even there. I mean, if you look at it, this area developed, I think in India also, we had Professor Narsimhan and all that started, they were probably the first group of people they have done. Professor Dijas Datta Majumdar was there, okay, they were like all real, great people, very senior people. And then of course then ISI, TIFR there, and then Kharagpur used to have, okay. As a matter of fact, at one time it turned out that there so many students came from Kharagpur, particularly Professor Chatterjee's lab and others. Then the national language of computer, image processing is like in Bengali. That also happened because most of them turned out those days were Bengalis. But thankfully now it has spread out everywhere. Now, Professor Dikshitalu is another person, okay, from ISC. So these are, a lot of great people who worked in that area. And what we then moved there, okay, then we realized at the master's level that I did something on biomedical and others, that medical imaging is one which is coming up, and that's where it got revitalized. Because before that, see, it was more like something can be done, but what is the application was not really there, okay. But I think once you see, the CT was coming up around 1970s and others, slowly into this, okay. That made a huge change. And then of course, when we started, we could not display our pictures. There was nothing there. And today is all pervading, right? So these were the problems that we had, okay. So now, and that's why it has come back because of this computing, display, all these things together, and the main buyers are actually all the medical, I think the imaging kind of thing. So it's really revolutionized the area.
That's very true. I was doing some research, and one of the things that interested me was super resolutions, motion, especially your book on motion-free super resolutions, and this is what you have to say in the opening paragraph. Super resolution from a single observed image is a highly ill-posed problem, since there may exist infinitely many expanded images which are consistent with the original data. I unquote. A thought flashed in me, where a crowd is taking pictures of a scene with their mobile phones with randomly different optical resolutions. Can they be used to recreate the scene with very high resolution and depth? Is that a possibility is being applied now?
Yeah, so if you look at it, actually we had a paper long time ago where we said that super resolution from zooming, this is we're saying optical resolution, so you try to keep zooming. So you see certain part of the scene at certain resolution, whereas the next part of the thing at little higher resolution, next like this. So if you go into that, then what happens is that then if you can create a model based on what is the highest resolution and assume this is like more or less the entire image satisfies that kind of condition, then based on that you can improve the quality on that. So we had something, and nowadays if you look at many of these mobile and other cameras, okay, they use multiple cameras. So the back, some of them 3, 4, I don't know, maybe next generation even more cameras. So all of them try to do it different things, okay. So people try to get it at different resolution, okay. There is different bit depth you can do, okay. So it's not like, so this is another thing called dynamic range. So if instead of the spatial, if you say instead of 8-bit, 12-bit higher, so then it's a dynamic range. Like taking picture in light and shade is difficult. So that can be done if you do it at different, way you take it with different apertures and others. So these are all possible things that one can do, okay, and people try to do it also. If you look at many of them, now most of the mobile, they have HDR, okay, mode. So that is high dynamic range mode, and that is precisely, we did it quite some time ago, that how to do it on the high dynamic range.
Something that is interesting again is the areas of computer vision. You also have interest in computational haptics and image processing. They're all sort of coming together in what is now being touted as metaverse.
Okay.
Now, this is probably the second avatar of Second Life. In early 90s, we used to have a platform called Second Life. We all tried to play with it, but our bandwidths wouldn't allow in India. Right? Now, this seems to be making a coming back. Just your thoughts on this.
Okay, so maybe before we go into that, we tell you the example that we did during this pandemic, okay? One of the most cherished item for today, it happened, I never attended any of my own convocation, okay? But nowadays all of them, they want to do it, okay? And it turned out that when you have this pandemic, no physical thing, so you want them to get the thing. All students said, no, we'll wait till the pandemic is over, okay? And then we come for this. And my philosophy there as a director says that calendar must be maintained, because if you don't know, there's an uncertainty, okay? You don't know what it is, because earlier also said, we'll have no online course, we'll wait till the pandemic is over and then we'll bring them back. Then we would have waited for 2 years, right? There's no, so then I told them, okay, since I belong to this area, let me work out something, okay, which is something very different, okay? So this is before all this term came up, metaverse and all. We'll do this 3D proper avatar based, okay, but complete your virtual reality enabled, your convocation. So what we did is that for each student, we said, okay, give us few pictures of certain nice pictures, okay, and your height, other things. Then we created an avatar for each person. They created an avatar for me, okay. They created an avatar for the chief guest, okay, and we had the background. Then what we did is that we created a complete package for all students, okay, to get that particular kind of degree, where the student's avatar got the degree from my avatar, or the medal from the chief guest's avatar, okay. And it's interesting, the two things I can tell on that is that when you look at the last years, okay, even that continued. And as the most interesting part was that I was supposed to give the degree to my son, okay. And we cannot meet because I cannot meet others, so naturally I cannot meet my own son also convocation. So my son's avatar took the thing from my avatar, even though at home we are meeting, okay. So that is number one. And secondly, when we had this, our chief guest for that, so I said, if you are not doing any physical thing, right, so let me go to the furthest possible point to get the chief guest. So last year it was, Jeff Hinton, okay, who is like, the most well-known in the machine learning person. So we said that we are going to create an avatar for you, okay. And after that, so he was very happy, and we said, okay, let me give you my pictures and all he gave. And we gave the thing back to him. Oh, he says, I'm delighted that now I have an avatar and I can show that. So he himself was very, nice, and he gave a nice comment. So the thing is that we have already done that. But the question I tell you, even though people talk about that, it's not going to be so easy. Okay, the reason is that it will be extremely painful, okay, because when if you wear this AR, VR, those kind of assets, actually there is a jitter, and your movement, eye compensates. You have what you call your saccades and all this thing. It doesn't have it, so it's like things moving fast, and you get very tired. So you cannot live in metaverse more than 5 minutes or so. If you are really young, maybe a little longer, but if you grow old, I don't think few minutes, it's just not possible, okay, unless they have to drastically improve the technology. As of now, currently the technology, would not let you go beyond that.
Yeah, that's I think a challenge, a research challenge, and also
Absolutely.
a cautionary tale for all the hypes that are going around. So since you talked about the COVID times, I have one more question related to that. You also worked on an area which perhaps is the biggest application, has seen the biggest application post-COVID, or will see. So you hold patents, for, among several others, Device and method for automatically recreating a content preserving and compression efficient lecture video, and system for creating a capsule representation of an instructional video. Both of these help in automating the cumbersome process of creating lecture videos. I have done some, I know how tough it is. What was your motivation? And this is right up there, this is what probably is required.
Okay.
What was your motivation?
See, motivation is always at the function of the time and space. Okay, so if you look at when the job was done, okay, it was a time when your display was very small, okay, and this is quite limited. So what we wanted to, so if you try to do it at that time, it will not be, you are not doing on, on your mobile, supposing you do it, your display resolution was so pure, if you are doing mathematical equations and others, if you are really writing it, you can't read it anything. So the idea was that you do something that as you, it'll just pick up the area that you are teaching at that instant of time, because you are, like a blackboard, you should focus only on that part of it, okay. So we picked up that particular job, so automatically finds out that, so that the legibility is very important, okay. And then you create that, so that automatically you can create that, and then you have basically like a cursor tracking problem, and then you just do it over there. We can also super resolve and things like this, so that it improves in terms of the quality, and then that is what is to be fed back. Does it have a relevance today? Now the display resolution, the bandwidth has gone up, okay. I am not sure that many people would go for that as of now, because simply now you get most of the thing, you get like almost 4K resolution in some of these things. So maybe now it's no longer needed, but that time, yes, probably we thought that was the motivation for doing it.
Okay. At this time, can somebody flag me on time? How are we doing on time? How many more minutes? It's 1. How many more minutes do we have? About, can I take another 8 minutes? Thank you. This is just about, finding problems to solve, right? How do you go about finding problems? Because for a researcher, that's the biggest thing. You have hundreds of problems out there. Which problem do you pick up, right? Are there any methodology to do it? Obviously none perhaps, but what is your overall approach to the whole thing?
So I would say that there are two aspects. See, first thing is that if you want to be really doing research, okay, which probably where you can really contribute, you have to first do your strength and weakness analysis, okay. Now I don't want to pick up a problem where I'm weak, okay. So I'm sure there are so many weaknesses that I have. So why get into that? You should always play to your strength, okay. Now over the years, you develop certain strength, okay. And of course, it's always good to see that if you have weakness, try to compensate, get improved, okay. So number one, that defines the kind of, the domain, basically you get a subset of the entire set of problems, okay, number one. Number two is that, what is the relevance of the problem? Okay. So maybe certain things may be interesting, but it's something to look at, okay. But may not have much other relevance in terms of either a technological relevance or societal, or maybe like application wise. If you want to solve something for the fun of it, it's a different thing. But if you want to do it with somebody over a longer period, okay. If it is a quick, I think low-hanging fruit, do it and get done, no issue. But if you want to stay longer, ideally that's what you want to do, okay. I mean, that's why I was trying to, most cases, I wanted to go to some point, bring it to the level where I have enough material and consolidate it in the form of a monogram, okay. Then I think then it's a more or less complete analysis of, I may not be complete, I would not say, but at least a size, to a good extent, you developed over time. That doesn't happen if you are just simply, crawling over problems and look at, okay, this is something because person X has done, person Y has done like this. So that's one. Second thing also, sometimes you look at the collaboration aspect. I know that there is something, this area I'm not good, but there are certain things that I see that interesting thing happen. And that's how I picked up haptics, okay, because it was not. I visited as a, to Technical University of Munich quite a few summers, and I find that they were doing something. And then look, I said, if you were doing it, I can actually mathematically give you certain kind of bounds, okay. Would you like that? Then they said, okay, fine. Then I said, okay, what about the corresponding learning on that? So we gradually, picked up. And then we set up part of the lab is like this. So then what happens, you don't come out of the haptics immediately, because then you stay there and continue. And then I think I have at least graduated, I think, 4 or 5 PhD in haptics area, okay. So the problem, of course, in haptics in India is, I understand that is still not there. I volunteered because there is a national project on digital heritage, okay, preserving the digital heritage, where you want to do things like, let's say Hampi and others, we have, I think it is under Shantanu Chowdhury, another IIT Kharagpur person who is actually the national coordinator for that. And they were looking at the way of preserving this. But the question is, we said, okay, can you touch that object also in some sense? I said, okay, I'll volunteer that part, okay. So we did that kind of thing. And then it was actually the exhibition and all. So it's an interesting thing, okay. And then you bring into the perceptions, then what happens? Because then actually it brings in a very interesting mathematical problem, which I don't know how to solve it. We're still struggling. Is that normally when you define a distance, okay, so you know that this is, what is the definition of distance? A is always greater than B, even if it is greater than 0.000 whatever something, right? But I don't want to do it. Human visual system, if 0.5 is almost same as 0.555 or something like that, right? So slack. So what is called like, perception is like a just noticeable difference. Can you put it mathematically in terms of the distance function? So these are the things it becomes, then it creates a new problem. And that's how you start developing, I think, most people do it like that.
Since you are both an administrator and a researcher, I wanted to ask you this one very important question. When it comes to research, you had those time of, so-called relatively unbridled freedom, right? Relatively, right? No pressure on time and no pressure on budget.
Budget, that has no, I don't think that's
yeah, relatively,
okay.
If you compare it today, but when you look at the research field, especially with the industry academia kind of a collaboration happening, I'm asking you, is there a pressure to show results because of which the quality of research is going down?
So, this is from the administration side, we just finished a round of promotion, okay? So all of them. So this question is very relevant to that. This statement that is always publish or perish is there definitely in the, this particular case. See, the issue is that, sometimes we go into the publication mode, and it is just like, you take the data or some observation, do something and publish. And you have large number of publications. But these are not really substantive in that sense, okay? Then I'm not very keen that this is something that we should be doing, okay? See, finally, you have to look at what is the intellectual satisfaction, At some point, you do something, and of course, you could always say in the hindsight, I could have done better. That's a different thing. But is there any learning for me? Okay, and I think I'll put it very, nicely. Once I had a BTech student, in the third year, used to come occasionally, every time used to say, sir, tell me, I'll do something. So once I said, like, I talked about what to bake. I said, I don't understand. Can you explain, read and do it, okay? And then he did a good job. He explained to me everything, and nice seminar, all those things. Then he says, okay, now tell me what should I do next? I said, you have studied, now let's, why not do that, implement, and let's see what can. And very interesting thing he said. He said that, look, I studied, you told me I studied it, okay. But what I study because I wanted to learn, okay. But here I find the machine learns, I don't learn anything, okay. Now, if that is not what I want to do, and I said, this is the kind of, the student we should be looking at. And I was so happy as a, as a guide that yes, I mean, this is nice. And as I, the last part I can tell you, that this person was applying somewhere, okay, as a PhD. And normally we write, reference letters, okay. And I want everybody to get somewhere to higher study. I always write very nice thing, okay. So this person, one of the person who wanted to take him as a student said that, you have written this, but do you actually mean it? Okay, like, so this is also I got sometime. Then I gave this particular, incident. And he said, I got my answer, I am taking him, okay. So this is the kind of thing is that, at the end of your journey, you would like to know that what is my learning, okay. And if I am not, that's the only satisfaction I would say. Publication and all is, of course, you have to show some output because society demands it, your job demands it, your students need because their career, it has to be there. But I think at the end, that's not the right, I would say, the metric.
I think that's an amazing answer that I have heard, because I just had a question on technology and courage, when I was hearing Professor Kincha talking about it, right? What is the place of a student who likes to take a contrarian view, in today's academia? You just answered it, amazingly. So thanks for that. Now I would like to invite audience to ask any questions before I ask the last question.
Yeah, that will be a tough question, not on
I just saw one line on your slide, and that line was, look into the data and you will find the problem.
You find,
This
I
what-
did not say that.
This was in one of your
No,
slides.
I said that it's not, rightly, okay, that I should know what to look for in the data, like the picture that you are saying, that is the.
No, I think what I noted down was, look into the data and you will find the problem. So I would like to know the secret of yours of looking into the data.
No, see, I have one, I think, advantage, okay. The advantage is that we are working on in the picture domain, right? So when you have this, I get to see what's there, okay. I mean, at the end of it, earlier days, many times it was like, what is the output you see, okay. So, it's very interesting that you ask this question that, when you solve something, let's say whatever the problem that you look at it, in the visual domain, since if I'm recreating and getting something, so I have a representation and I can find out that this is where the error is, okay. And it's always, with time you get to see that where the problem is, okay. And it's always true, like for example, you have been, let's say for example, grading students, the answer sheets, okay. Now, we can do a lot quicker and precisely we know where the problem would be, and we look for those rather than reading everything in details, because, right? So, and I can give you an example that once I used to, to give in my exam, open book, your mid-sem, okay, which is like, I used to give them 7 days, okay, not just 1 day or something. And I said, it is open everything. This is the setup problem, you do it, whatever. Now, when they submitted, once I wrote to one of the students' answer sheet that, did you solve this in a rail station, okay. Now, then when I give this back, okay, the student said, sir, how did you know? Okay, I solved actually in the bus station, okay. Then, and he mailed it to one of his friends who submitted this one, okay. He says, like, I was actually traveling and during that process I did it. Then I said, look, I have given you 7 days, okay, and that means you need to think and do it. What I see the answer is just like, quick, rapid fire, you have done it somewhere very fast. So, when I saw that, based on that, I made a comment. It's not that I knew what's going on, okay, but it turns out that he was doing in a hurry somewhere. So same thing is true, that when you actually look into the image, it prompts you that this is where actually the problem is, okay, and this is what I have to do, solve this, okay. Like for example, when I talked about the edge getting shifted, I can mathematically write down how much it is if I know the nature of the function. Okay, but if you try to look the intermediate things, sometimes I tell my students, show that. Okay, I want to see that particular thing. That gives that kind of feedback, and then you can say, oh, this is now I need to correct it. I don't know whether I answered your. Okay.
Thank you, sir, for that question. Any more questions? Before we close, I will ask the last question. Sir, who has had the most influence in your life? And what would you like to be remembered for and as? More, as a researcher, as an administrator,
Okay, so you have two questions.
Two questions.
Right, so not one. So the first question is that, the contribution that, who are the one who actually help you? There are many. I think when you grow up, definitely I would say my father played a big role, okay, in terms of shaping that, what should be the path, okay. That of course continued. Then I was lucky to get a lot of good teachers. Many of them, like in IIT, in Narendrapur, we get good students. Teachers were, by the way, was not so probably good in my school, okay. But even when you UC San Diego, we had a professor, Elias Masri. He was such a good teacher. G.S. Sannel, for example, in IIT Kharagpur, beautiful teachers, okay. And they could actually, you see a lot of value in terms of what they do. So definitely they, help you. Now, so it's a collective thing. So then together, that should be remembered, and that's, definitely, I should be thankful to all of them. Now, on the other hand, the second thing that you were saying, that what you would like to be remembered for, I would completely put it in this thing. I would not like to be remembered at all, okay? The reason, I tell you what, there was a very nice, I think there is a person called Sharvapriya Nanda, I think probably, who is the head of this New York Vedanta Ashram. I think he has a lot of very beautiful kind of YouTube videos, okay, and one of them was, in some sense like this, and I was listening to that, okay, that, it's like, topic is Amritasya Putraha, okay, that you want to be, immortal, right, and if you want to be immortal, right, then of course you realize that you can't, okay, so what does it mean, in that sense? Of course for them the Vedantic philosophy would be different, but if you normally, the misinterpretation or something would be that since I know that finally I have to leave, okay, you would like to set up, and that's what the king, others, they want to say, okay, set up this, place like Subhasis Chaudhary Award or some pillar or something, Ashoka's pillar and others. You try to do that, okay, so that it's not me, it's my kirti, okay, which stands the, the time, whatever. But to me, that's, not the right thing to do, okay. See you in time, space, everybody comes, they have a position, others, you do something. But finally, we are supposed to, the Bible says, thus thou art to the while returnest. Okay, you have to go back. Okay. And why would I want to leave a trace? I should not be. I came, there, enjoyed my time, tried to do whatever I thought would be the right thing to do. And then I just leave. That's it. I think I would stop at that point. Okay. Thank you.
Thanks a lot for a wonderful session. Due to paucity of time, I had many questions. I had to skip many of them. So thank you, sir, for joining us today. Thank you. Thank you.
Thank you, sir. We never fail to learn from teacher. So when I was doing my master's at IIT, I was told signals are function of time and space. And today I learned motivation is also function of time and space. Thank you. So on this note, let's break for lunch. Lunch would be on the ground floor below. On the, this is east, north, what it is? east side of the corridor, open area, very informal atmosphere. So please, go for the lunch. Thank you. In case if somebody has not noticed the schedule, after the lunch we have a very nice panel session with on very concurrent topics of computer vision and signal processing. Please be back at 2 o'clock here. Thank you.
So we'll get started. We'll get started. We're starting the panel discussion, and after I just introduce the panel, if you would like to give any opening remarks regarding open challenges and trends, if you think it is appropriate.
Okay, okay.
Hello everyone. Welcome back after lunch. It must be a difficult time to concentrate, but I think what do you say? This is time for Sandesh, as Professor Saragopan mentioned, right? I mean, let's get a discussion going. I mean, let's celebrate Professor SC's area of research, computer vision. Let's talk about what are some, let's say, broad trends that are there. We may not be exhaustive, but at least we have an excellent panel. Professor SC himself. We also have Professor Venkatesh Babu from IISc. He heads the Video Analytics Lab, and he's one of the, his is one of the best computer vision groups in the country. We are very privileged to have him here. So, I mean, in terms of trends and say open challenges, I think thanks to Professor S.C.'s lecture, I mean, we know how things are moving, right, and how things started moving after the deep learning paradigm, and particularly after ImageNet and 2012 Alex network and so on. So the area has really taken off, right, and it has sort of influenced so much in terms of every problem that we attempt in computer vision is sort of in some sense well affected by deep learning in terms of performance that we get, in terms of application and so on, right? So that's, I think, one landmark moment, right? 2010, 2012, not only for computer vision, but also for speech, also for natural language processing, let's say AI, right? And so after that, I think, I mean, in terms of what has happened, even in, say, just the object recognition, detection, segmentation, and so on. So a lot of interesting developments have happened, performance have improved, right? And people, I mean, not just are applying it for, say, recognizing something, but they're also even applying for basic image processing tasks, right? So image goes as output, image comes as out. Image goes as input, image comes as output, which is the typical image processing task, right? So even segmentation or denoising, everything is posed as, let's say, a deep learning architecture. Maybe you go through the full pipeline, get some semantic meaning, reconstruct, and so on, right? So a lot of interesting things have happened. And in terms of what open problems it has sort of given us, right? So for example, as Professor Venkatesh Babu will be talking about, is it perfect? I mean, are deep neural networks perfect, or do they have, say, some basic challenges, as Professor S.C. also pointed out? I mean, we don't really understand fully, right? And these networks could be prone to what are called adversarial attacks. And if there are adversarial attacks, how do you defend, right? How do you make the models robust, right? So that is one topic that Professor Venkatesh Babu will talk about. Dr. Biplab, who is a PhD student of Professor S.C., so he has come all the way. Yes. So he is a PhD student, again from IIT Bombay, working also with Professor S.C. And he is with the CSRE and C-Minds from IIT Bombay, and he will be talking to us about using deep learning for remote sensing applications, and particularly cross-domain and limited supervision, which is, I think, a very important area, given that deep learning is very data hungry. What do you do when you have limited supervision, right? And we also have Dr. Sri Krishnan, again, PhD student of Professor S.C., right? And he's a senior scientist at Philips, and he has extensive industry experience, and he will be talking about medical vision and applications, right? And we also have Dr. Vishwanath, who is an assistant professor at IIITB, and he has worked at Samsung for several years, and he would talk to us about vision and NLP, right? Given that you can also, just like you can convert an image into a vector, you can convert a word into a vector, and there are, and then it's a neural network, right? So can we think about problems in the vision and NLP space, like captioning or question answering and so on, right? And finally, myself, I'm Dinesh. I'm convening the multimodal perception lab here, and I will talk about vision in the context of conversational AI, how one could go beyond, let's say, text input, text output systems to maybe have an avatar speaking to us, and also have a video on the user, and be able to understand the user better, and go towards what do you say, a natural human conversation, right? So it's an exciting set of topics that we have listed, and really look forward to an interesting discussion. And the theme is, say, open challenges, trends, and problems in computer vision. So that is the theme. So we'll have each panelist talk about their thoughts, maybe using slides, for 10 minutes max. So maybe at 8 minutes, I'll give a cue, and then maybe we'll stop after 2 minutes. Let's have a hard stop, because we have busy people we don't want to hold them for long. And then after that, we have 20 minutes allocated for question answering. So we can have a freewheeling discussion. We'll probably change the chair orientation and audience. We have students here. Please feel free to ask questions and make it an interactive session. So let me start off with Professor SC. Maybe request him to give his opening remarks and tell us what are still some open challenges and trends. Yeah, please.
Thank you, Dinesh. I think we have been excellent panel waiting, I think, to give their whatever the thought on this particular area. But, somebody who has worked in this area for a fairly long time, I think I started, as you said, sometime like 84 or, it's a fairly long in this particular area. Initially I can tell you that when you start doing it and you see that some point, nothing, even though you develop a lot of theory, a lot of nice kind of mathematical thing, a lot of publications coming out, but at some point we realize that not much is happening on either in the application domain, and the area is not getting a boost. Okay, so this was something I'm telling about like 84, 85, it could be around that time, 80. Okay, so there was some stagnation came in. And then what happened, then by the time this medical imaging came, okay? And I think today we're happy that we have Sri Krishnan here, from that particular domain. See, because then it became like a massive industry, because health is something where everybody has to attend to, okay? And if you look at today, the X-ray, it's alone, okay? It's something like $13 to $14 billion business in US, okay? Similarly, if you look at in the different types of diagnostic relationship in India, it's also something like, I think, around 75,000 crore, the total national thing. And you can imagine the other MRI, others, that all this thing happened everywhere, plus other countries. So suddenly you see that the consumer market is ready, okay? And that gave a big boost to that area, okay? And of course, medical imaging is one which catapulted that area into the next case. Now moving forward, okay, this is happening, let's say when we started as a student, I remember we took a course on those days as neural network, and now what you find is that there is a large, you have the display system has improved, your computational power has improved, memory has improved, bandwidth has improved, okay, all of them. So almost like we are saying it's limitless, so which is of course not, but there is definitely, how it started. So if you look at from that point of view today, okay, this neural network has suddenly, the machine learning has opened up a huge kind of potential. And if you see that today, computer vision has been, if I may use the word hijacked, which may not be the right word, has been hijacked by machine learning. There is no life in computer vision other than machine learning, okay? So even people like us, we never learned machine learning earlier, suddenly we are forced to read now what is machine learning, so that our existence itself is in trouble, okay? Now, if that's the kind of scenario, a lot of new things, I think some of the problems were old, okay? But it's like a old wine in a new bottle, okay? But probably you do a little bit of shaking, okay, and getting better test, okay. So if you look at that way, many of the things now we're getting better results, okay, maybe faster results, okay, and some of them are ready. But the question is that, the challenge I think, is that again we are seeing an application stagnation, okay. Even though we talk about metaverse, we say that there are a lot of other things that could happen, but we are not able to now put into the proper application, which would invest a huge amount of money to take it from the universities and Google or other the Amazon lab to directly into this. Okay, so you will see that occasionally, like when you buy in shop in Amazon, suddenly you say if you are buying this shirt, maybe this is the one as a recommendation system. Sometimes you get completely garbage result also, as a recommendation. So the question is that the robustification and some kind of, I think, the performance guarantee. which somehow we have not been doing it, you know. And this is the earlier case when we talk about something, even though we were not doing as good as what we are able to do it, we could give a performance bound for many cases. Okay, we know this is the best we could give, take it or leave it. Okay, now that's probably one of the challenge. So our job would be, I would say, for the next 10 years or so, you know, we have extracted a lot of this mileage out of the machine learning, low-hanging fruits, they, you know, get it done. But the question would be that how do you take now, okay, to something so that I can practically use, right? Where I am safe, maybe it's a medical area, if you look at it, okay, I don't want the decision process, but the decision support at least, okay, can be there. Similarly, if it is some other cases, you know, people have been doing autonomous driving and others, okay, which is good for cases like in US and others, but in India it's, you know, probably not needed. And secondly, you know, my objection to the autonomous driving is that if everybody is in autonomous driving mode, okay, then actually you don't need any intelligence because they can be connected and they can program it itself, it can go like this. There's nothing, you know, except occasional pedestrian coming in and getting it. That could be the only danger. There are a lot more other better techniques to do it. So given that, I think we, in this particular discipline, have the challenge, okay? And let's hear from the experts, okay? I'm not the expert in machine learning. We have Venkatesh Babu, okay? There's Biplav, I think this, Sri Krishnan, and Vinod, right? Suhas, Vishwanath, okay? So let's listen from the expert, okay? Thank you.
Thank you, sir. Thank you. Slides will be up. You want to use this or call it?
Okay. No. Good afternoon, everyone. So in this panel discussion, I just wanted to pick up a topic which is quite interesting as well as very important in machine learning community. So that is vulnerabilities of deep neural networks. You can change the slide. Okay, that's better. Yeah, so deep learning application that we are talking about has penetrated various domains, right? So even if you take computer vision alone, you can see these are various applications starting from autonomous navigation to healthcare and robotics, speech processing, NLP. So all these areas are very much affected by the recent developments in deep learning. So yeah, so whatever the model that we are developing using a lot of training data as well as compute power, are they giving us very reasonable or robust models? So that is what we are going to examine today. If you look at this particular image, we are adding a very small perturbation to the image, that is what is on the left hand side. We are adding a perturbation which is something, it looks like a noisy pattern, and after adding the noise, what you are seeing on the right hand side is the noise added image, which we call this as a adversarial image. Okay, so if we feed this right hand image, then your machine learning model predicts something very different, which has nothing to do with the actual class itself. So this shows, so what we perceive is very, very different from what the machine is perceiving. So there is a huge gap between the perception. So even a very small perturbation like this can derail your deep model, which is trained with millions of images and millions of parameters. They can be easily fooled by adding a very small perturbation. Okay, so that shows, though it is doing very well across various domains, it has a huge vulnerability in this. A small thing can affect the huge deep model very much. So if you take an adversarial in real world, that was the imperceptible perturbation we can't even see, whereas you can also create a visible perturbation, something like this. For example, if you look at this 35, there is a small sticker added to the middle stem.
it actually reads the limit as 85. Though it is slightly perturbed, the machine actually reads this 35 as 85. Okay. Similarly, not only in this domain, you can look at the other domains as well. For example, this is the adversarial spectacle, where you can wear the spectacle and you can become somebody, some other celebrity himself. Okay, so you can gain access by wearing this kind of a spectacle, which is something like printed. Similarly, the stop sign can be read as some other speed limit or something like this by putting stickers, appropriate sticker at correct locations. Mm-hmm.
Unit of acceleration is wrong. Mine's for, per hour. How can you get?
Okay. Anyway, yeah, sure. Yeah, it's accelerating too. Yeah. So this is from medical domain. You can see there is something called adversarial rotation. You take your image and then rotate in a specific angle. Okay, and these are measured angles. If you rotate to this angle, then your deep model actually fails here. So benign sample becomes a malignant sample. So we are not doing anything adding to the image or something. It's a rotation alone can make your model fail. Okay, so these are examples from various applications. So how to craft this adversarial samples? It's quite simple. You have a loss surface, right? All we are doing is, when you do back propagation, you just measure the gradient, right, with respect to the image. So all you are going is you're going along the gradient instead of going against the gradient. And then once you go along the gradient, you can create the perturbation like delta x along this. So it is like a size of the image. At each pixel location, you get some kind of a gradient value. So now you take this image gradient and then take a sign of this +1 or -1 and then scale it by a epsilon value. So the epsilon is kept for imperceptibility constraint. It should not be visible to the human brain. So just add this delta to your original image, that becomes your adversarial sample, as simple as that. So it's very easy to create such adversarial sample, which is on the right hand side, using single step. It's a very fast way of creating the adversarial sample. So, and this X star, if you feed it to your model, though we can't feel any disturbance in the image, the whole model derails and gives you a very wrong prediction. Almost 90 to 95% of the time it fails. So that shows, though it is performing much better than our brain capacity, it has an inherent vulnerability that is far from, whereas we cannot mistake the image by looking at this X star, right? So, yeah. So think of various situations like this. So if you are reading a school signboard or something else, and this is going to be a very disastrous situation. And one more major problem that we face is the transferability of these adversarial samples. So I don't have the model with me, but you have your own model, right? So I can train with my own model and create adversaries and transfer that adversary to your model. Again, it can attack your model, though not at 90% of the time, at least 40 to 50% of the time it makes your model fail. So that shows, even if you don't have access to the model itself, you can craft the perturbation with your own model and then transfer that attack to any other model. That shows that's a much more dangerous situation. Again, 50% of failure is unacceptable in any application, right? Also, I want to highlight, if you want to create a robust model, so I'm a true believer of, I just want to use robust model in my application. Then if you look at these numbers, for example, I gave the statistics for MNIST, which is the smallest data set to ImageNet. So you can see the normal training is actually, the accuracy of the normal training is somewhere 99 starting from for MNIST to almost 82% for ImageNet. Whereas if you look at the adversarial training, this is the last two columns that I'm showing, I want to make my model robust, right? And I do adversarial training and made my model somewhat robust. Then I can see the clean accuracy, it falls drastically from 87 to 62, 63%. You get a 20 to 25% of accuracy cut even for your clean samples, okay? Which shows us all this that we gained in deep models by doing so much of training, all this thing, looks like it's at the cost of robustness. If you want to make your model robust, I think it is not going to be better than our old feature engineering based solutions, okay? And we are still struggling to get reasonable numbers for the robust accuracy, which means if I present the adversarial sample, how much accuracy I get. That is very pathetic. You can see the numbers, it's hovering around 30 to 40% something. So we are nowhere near reasonable accuracies when we try to generate our robust models, okay? And there is a huge potential to improve this. Also, I would like to tell about the robustness, the cost of making a robust model, which is very, very expensive. For example, we do 10 times more backpropagation to create a robust model than a normal model, which means it adds 10 times more complexity, 10 times more flops, which is not acceptable. For example, ImageNet is never trained actually in adversarial situation because only Google, Facebook, they have so much of GPUs. Whereas in academic situation, we take few months to train ImageNet in adversarial setup, okay? So creating such adversarial model is really, really challenging, and getting a reasonable accuracy seems to be much more challenging. So this is going to be kind of a major problem that we are going to face in the, as Professor mentioned, next 10 or 20 years, I don't know, okay? But one thing is we want to have robust model at the end of the day because all applications demand this robust model. Thanks a lot. Yeah, thank you.
Thank you, Professor Babu. So a very interesting topic, but we'll reserve the questions for later, please. Yeah. Now I'll let Dr. Biplab continue.
Okay, so good afternoon. So I'll be talking about a very specific application domain, which is remote sensing, satellite imaging and all, because I feel nowadays with vast amount of satellite data, many things can be done, right? And so what I'll do, I'll go breadth of problem that we have been doing, of course, together with Professor Suvasis, and I'll mostly define the problem definitions, okay? So, so these are the images taken by some, with some light source, preferably it's the sun, with some active or passive devices, and we image the Earth's surface, right? With these images, and there are many missions coming up, both from ESA, NASA, and all the other countries, and also we have huge volume of satellite data. And this satellite data could be of different properties, of different spatial resolution, spectral resolution. It could be simple spectral data or radar data. So there are a variety of data that we can acquire for a given area, right? And many problems that turn up. For example, for a given area, we can have images of different spatial resolutions, as you can see in the figure below. I mean, it varies, right? And with different zoom factor, like we get to see different things. There could be hyperspectral data, which are like continuous in the EM spectra, and they're how to select the bands, right, for application like mineral studies, geology and all. They need to differentiate between the chemicals, the object. So how to learn the actual spectral features. And of course, the less data problem, how the models generalize over the geographical areas. So all these are some of the challenges here. Now, with this, the first problem that comes into mind is to do semantic segmentation, right? So given these images, we want the pixel-wise levels. Now, the first set of 3 images are very high resolution, as we call them, because the spatial resolution is less in centimeters, basically. Now, with this image, the problem could be like there could be occlusion, clutters, and all these things, so we cannot get good segmentation. So then people have started using some other modality. So in the second figure, I show results of spectral data along with some depth maps, so the DSM as they call. So with this multimodal input, can we make better segmentation? So that is another important problem that people do. And using the second modality has some sort of regularization effect, so we can train the model with less amount of training data. Now going further, yeah. So when this multiple modalities they interact, so the question comes, how can we get the better feature out of the modalities, right? So we have worked extensively on the idea of how we can apply the self-attention, cross-modal attention and all this stuff, so that we extract meaningful feature from all the modality, fuse them, and then do segmentation. So in multimodal direction, another interesting problem could be, so assume that we have like data from multiple modalities during training, but due to sensor failure or somewhat, during testing some of the modalities are missing. So how can we hallucinate on the fly the missing modality, and then we apply the trained model which is trained on the multiple modalities directly. Yeah. So now coming to the hyperspectral data itself, because it's some images with like 100 to 100 bands, right? And these are again rather low spatial resolution data, but because it has high spectral fidelity. So here, just defining a network which can learn both spatial and spectral feature together is not a very easy job, right? People have tried 3D CNN and all these intensive models for that. But what we wanted to see, can we use a simpler model and still reach the accuracy of a like very cumbersome model? So we worked on this spectral attention, spatial attention, adaptive feature learning, those kind of stuff in the first work. And in the second case, so CNNs are basically feed-forward network, right? So how can we incorporate the feedback connection so that we have connection between all possible layers and all this thing, right? So we use this self-looping kind of architecture, and we see that even with a 2D CNN, 2D convolution model, we can actually beat more sophisticated, more deeper kind of structure. So this, we call this Hyperloop net. It's basically a self-looping neural network structure. Okay, so now moving forward, now of course, like it's not possible to label all the data. Due to this low spatial resolution, there could be impure pixels, and so a better way to do is few-shot learning. So now within few-shot learning, of course, the major problem that comes into play is the overfitting problem, right? Because we have very less training data. So we have looked into how can we incorporate uncertainty and the related kind of measure to obtain more generic kind of feature learning from very few level samples. And here the things are pretty difficult in the sense we need to take the spatial, spectral, both the things into account to learn generic features. So this is, we did something like a Monte Carlo drop block kind of stuff to do some sort of regularization in terms of uncertainty. Now moving further, standard problem could be like, within the few-shot scenario, what happens if we get to see some unknown sample during testing, right? So we call it a few-shot open set recognition. So even there are a few works in vision field also. In remote sensing, we came up with a meta-learning based solutions, which basically learns a pseudo kind of boundary between open set and closed set, and learn the open set features and doing both the things together, right? So this is one nice problem that could we came up with. Now going in another direction, so from multi-input, single output, so let's do the other way around. So from single input, can we get multiple outputs, right? For example, doing multiple dense prediction tasks together. From a monocular image, we want to do segmentation, depth estimation, surface normal, all these things together. So it itself is a challenging problem because designing a network for multiple tasks is not an easy thing, right? So we have one input image, so there could be one common feature extracted. So how the tasks interact with each other, so where should we segregate the shared feature versus the task-specific features? These are some of the intrinsic questions in this particular area. So we did some sort of task attention learning and all for this purpose. Another interesting problem could be task transfer, right? So we have, for example, say, a label for segmentation and depth for one domain, but for another domain we have a label for only one task. So how can we use the cross-modal information and between task information to get label for the test task in the other domain, right? So we call this task and domain transfer. Now, of course, we want the models to be small enough, the compression and all these things are needed. So, and of course, there are many approaches, quantization, knowledge distillation and all this thing. But we did not want to do a standard distillation from a teacher to a student. Rather, we wanted to see, can we do distillation within a network, right? So can we distill the property of a deeper layer to a shallower layer? So we came up with this idea called self-distill multitask network, so which actually regularizes a network by just distilling deeper features to the shallow features. And during inference time, the shallow part can be used actually. And we did that both for hard sharing and soft sharing with multitask learning. Now, finally, the last part. So the domain adaptation generalization has one of the problems that we have been looking into for a long time. So basically, the idea is like we cannot expect a very good data, like the training and test distribution are similar. It doesn't happen. So typically, there is distribution gap between training and testing. So right, in this case, how can we ensure that the trained model generalize for some different kind of domain? So it's a domain adaptation problem. So here we came up with 3 interesting problem definitions. I'll just mention them. So by the way, so there are two possibilities. One is like single source, single target, one training domain, one test domain, and the other could be multiple training domain and one test domain, right? So this is single source versus multi-source. And in the test domain, there could be known classes or known plus unknown classes. Accordingly, we say it closed set or open set domain adaptation. So we worked on three interesting problem definitions. We started this multi-source open set where we have some labeled source domains. They share the classes, but in the unlabeled target domain, there could be known as well as unknown class sample, right? So how can we classify the known class data and then detect the unknown class data? So we tried to do this in this way. So from all the source and target domains, the known classes should be clustered and the distance with the unknown class should be maximized kind of thing. The next problem is, so this is a very recent work. So here we wanted to go in a low data regime, right? So we are doing single source, single target domain adaptation, but in the source domain, you have very few level data. And in the target domain, there could be known as well as unknown classes. So we call this few shot open set domain adaptation. So here also we came up with some sort of adversarial technique that account for the low data and then do this alignment and recognize the unknown samples also. And finally, nowadays, you know, the trend is to go to a continual learning setup where we do not expect the model to be stationary. Data can come at different time instance. So here we introduce the problem of what we call the continual domain adaptation. So we assume that the source label source domain is coming at time t equals to 0. But afterward, all the target domains are coming and they're totally unlabeled. And at any point of time, we have data of the current time step, all the previous data not accessible. Due to privacy and all these issues, and the testing can happen from all the domains, right? So that's the challenge. So there could be catastrophic forgetting, there should be plasticity and stability dilemma, and there are many problems that occur in this case. And if there is domain gap, as I show here, the problem becomes even challenging. So we came up with some sort of rehearsal-based, generative rehearsal-based approach where a GAN type of model is trained incrementally, and so taking all the issues into account. So just summing up finally, so there are of course many challenges in remote sensing, of course both from feature learning and just generalizing over multiple domains in a continual manner. So there are many scope out there, okay? So I think I should stop now and then take the questions later, yeah.
Thank you, Dr. Biplab. Over to you, Dr. Krishnan. I guess you don't have slides, so that's...
So thank you first of all for inviting me, and thank you, Professor Chaudhary. So I didn't bring or make any slides because I joined Philips recently, and then we would have to go through the entire process of going through the legal and so on, even if it's a very common, very open work. So I'm just trying to, I'll just talk my way through the next 5, 7, 8 minutes. I've been working in medical imaging. So my PhD topic was in some area called active contours. I think probably that's the different one. And after that, I've been in completely medical imaging, segmentation, registration, classification, working in GE Global Research or Samsung for some time and so on. So some of the, and now there's this entire deep learning wave and AI and everything. So I'd more like to kind of talk or just focus on the open problems, many of which we are aware of. But still, I'd like to kind of categorize it into 3 kind of buckets, especially when it comes to medical. One is about the fairness of the data, which NIH has talked about, or NIH or even FDA. So because without any disrespect to any group which are working, we see so many solutions about COVID detection in X-ray in the last 2 years. But really, none of them really make the grade because either the data is not collected properly or it's lot of things. But so representative collection of data, and then probably the question then becomes, how do you define a fairness of data? Right. I mean, disease is often spread across the world, and there are a lot of confounding factors. That's number one. And the other part is, as Professor mentioned in the morning, the sample size problem. Like, as you blow up the number of disease, age, gender, race, the dimensionality blows up. So huge number of data, but what is that optimal point? And along with the data, there are these problems of how do you collect it from different centers. I'm talking about more from a company perspective. You have to collect those data, anonymize them, bucket them, separate them, store them. That costs a lot. You have to archive them. And for FDA, you might have to show a whole lot of documentation. This is enormous cost. So we have to have that balance. So this fairness, how do you measure it? How do you quantify to an extent which is practically possible? So that is one of the challenges. And for now, everyone or a lot of people sort of work on identifying multi-center data. I mean, 4 or 5 centers collect as per the clinical study protocol and get on with it. But FDA, as I said, is getting stricter on it, and not just why should FDA beat us a stick? After all, we might as well end up in that machine later on. So we might, take some better precautions from now. That's one part of it. The second challenge, which is which we see often a lot, is about interpretability. We have this classification models, as we took the example of chest X-ray. Now, a lot of pneumonia kind of thing can also give the same kind of thing. So how do we interpret it? And that's a lot of conflict between is AI going to substitute radiologist or no way? I mean, probably not. But the interpretability is what is, there are GradCam and every other day some other interpretive. But when we really look, even in the simple case of COVID, and then we try to, do we really see the features there, which is where we want to see? Many a times, no. So this is one how do we interpretability, and that's how everyone will get a confidence on it. So that's one part of it, because last year we were working on a project. I mean, it was a pulmonary embolism RSNA challenge data set, 7,000 images and all of that. So classification wise, yes, on a slice based 93%, 95% we could get internally for our, but when we see the maps for any of these, really not interpretable. And the second thing is when we want to have a complex set of algorithms. So for in this case, without going into the detail, we did again a deep learning based anatomical localization of the lung area, because the scans could start from here, end here, or start from here to end here. But pulmonary embolism, it's a lung based So there's one model for lung localization, one model for slice based classification, and one model for the entire volume classification, because that's what we really need. Now, if we want to have interpretability of all of this, it's going to be very tough with the current set of, so that's a sort of a academic challenge. And the third part is about, this is more about data and labeling, which we talked about earlier, that fairness of data, more richness of data. The problem is about the tools, collections, anonymization, everything which I mentioned. But the other part of thing is also the annotations and the labeling part. If it's a classification, it's maybe okay. But when it comes to segmentation, especially 3D models, we want to segment the lung tree, or you really need an expert. Or if you want to really map the cartilage, knee cartilage for arthritis and so on and so forth. Cartilage is very thin. It will appear in only certain views, sagittal, coronal, one of these views. But labeling these is very time consuming, costly, and all of us know it. Radiologist time is better utilized in treating a patient than putting some marks somewhere. So methods are coming up, semi-supervised learning or self-supervised. But again, there's a lot of challenge over there as well. And finally, one more thing is about federated learning. This is probably related to both managing the diversity of the data, maintaining privacy, as well as achieving the sort of the performance required. So again, there are, in this case, what I can see is, at least without taking too many company names, NVIDIA has a good package, federated learning and all of that. Okay, so yes, but we need a lot of more algorithms for this fairness purpose. So I kind of stop here. I thought I would finish earlier, but then 8 minutes are over. So yeah, I think that's all. Thank you.
Thank you. Over to you, Dr. Vishwanath.
Good afternoon. Okay, so the in the next 10 minutes or so, I will briefly touch upon some recent advancements in vision and language, some of the works that I do here. So if you look at traditionally the vision and language communities have not spoken with each other for a few decades. The scientists or the researchers who have worked on vision, they developed their own techniques for a few decades, and the language was primarily focused on the semantics and syntax of the language part. And if you see the way we see the vision modality and the language modality, they are seemingly non-connected, right? Vision is primarily an inherent modality that is that can be understood by any living being, like humans or animals and all, but language is something that we developed. But the cognizer in our application is the same, that's the human. So the modality of language and the vision has a common cognizer. So that's where we see that they can be interlinked, and they can have mutual understanding, and there are applications that actually very much will get advantage when they can be connected with each other. So let's see some of the applications. So if you look at the developments that has happened in this domain in the last 5-6 years, we have seen that the language community has inspired the vision community. For example, the transformers that has brought in the invention of transformers, which has been primarily inspired by the attention-based mechanisms, has come from the language community. But we are seeing the last few years that it is transforming the vision community in a big way. And it can be even, some people even say that that could be, the transformers could even potentially kill the CNNs. So we never know, we have to wait and see. So let's see some of the recent applications or use cases which got triggered by this recent merging of these two modalities. So these are the two strongest modalities, but they are seemingly different, but there are certain scenarios where we can see that they come together. For example, if you look at the problem of visual grounding, given a sentence, we would ideally like to pinpoint to the location in the image where the sentence, the specific thing in the sentence is describing. For example, the sentence says that a pink umbrella carried by a girl in the pink boots. Of course, there are two girls here, and they are having two different colored boots. So the visual grounding task would ideally like to pinpoint onto that umbrella that the girl with the pink boots is carrying. So these kind of language-based pointers will be very helpful in, for example, drone-based surveillance, where you are not having, you are looking for some specific things, like for example, a natural disaster, and you might be wanting to see people trapped in some rubble, or for some specific things in your mind, and you can give this command to the drone, and it can actually say the yes signal, I have found something like this, right? So it's a very natural way to interact with an algorithm that is sitting in a remote device like a drone. Similarly, there have been a lot of interest in visual question answering. So we can potentially ask questions about a content of an image, and the network, the algorithm can reply back based on the content. So for example, I don't know if the questions are not very clear, but how many pieces of the pizza slices are there? The network should be able to answer, there are so many pieces, right? So these are certain scenarios where vision modality, vision-based understanding, as well as language-based understanding is very much required. So typically in the solution pipelines that we have seen, we see a visual recognition module which tries to understand the content of the image. So we see a typical CNN trying to understand, a typical FASTA CNN trying to understand the objects in the image. And there is a language modeling. So here we need to model the question, right? So we are asking a question about the content of the image. So there is a language modeling part. And then there is a language and vision dependency modeling. How the different entities in the image are connected with the entities in the language. So which are the application scenarios where we see this kind of vision language interplay comes into picture? So if you just look at scenario could be like a visual user. As a user, I don't have access to the visual feed. Then I could be asking a question about the visual feed because I don't see it. Otherwise, there's no point in asking a question about something that I already see, right? So one such scenario could be a wearable to help the visually impaired person to move around. The person has to ask a question about something that he might have kept somewhere in the indoor scenario, or even in the outdoor scenarios if there is some obstacles around. So this is one scenario where there is a visual feed for the algorithm. That means the camera the person is wearing, but there is no visual feed for the person as such. But the person can interact with the system through language, right? The person can ask questions about the surroundings and get the answer in an audio feed. Like the answer could be a language, but it can be finally converted to a speech, right? So this is one scenario where we have a lot of scope for developing systems which actually understands vision and language together. And there is remote surveillance using drones, where you don't have the luxury of visual transmission or visual content broadcasting, but you can actually speak or ask questions which is very less bandwidth, and then you can get answers from the remote broadcasting. So this is another area where we can actually have this kind of vision language based applications helping. And there is another scenario. You have access to the visual feed, but you might be wanting to know more about that. For example, if I have this image of a subway, and if I ask the question, do I get a sandwich here? That answer is not right there on the image. But as a vision algorithm, the algorithm can understand it's an image of a restaurant, and there is a word subway, and we can use an external knowledge graph to understand that Subway sells sandwiches. So combining that information, that there is a restaurant and there is this word Subway, and that is not about the subway that like a road subway, but it's about a restaurant, and that Subway restaurant sells sandwiches. Actually the algorithm can answer you that, yeah, indeed you get sandwiches here, right? So this is another scenario where the user can see the image, but the knowledge is not inherently present there, but the knowledge is there in, say, in the web. So these are the scenarios where actually vision language based interplay actually helps. So there are different ways people have progressed on this different problem statements, but one of the most successful method that has found good accuracies is using multimodal transformers. So transformers as such has been using attention mechanism to improve the representation of a modality, like for example a word representation or a sentence representation. So extending that philosophy, here people have attempted to solve the question answering problem statement by dividing the input data. Like for example, I have an image and I have a question on the image. I will run my faster RCN and I get the objects in the image. For each cropped area in the image, I will feed to my transformer module along with the question I asked. So the first part is about different question words, and then there will be detected object representations. And even if there are some sentences in the image, for example, this image contains a signboard which have some speed limit. So the question is about what is the speed limit on this road. So the answer should be given from the image. So the transformer input will be the different words in the question, the contents of the image fed as the object representations. Like we can run a object detector and get the object representations, and then we have the OCR running and we get the OCR tokens, and together all these different tokens are fed to the transformer, and we hope the transformer learns to attend to the relevant tokens based on the relevant questions and answer you from a predefined vocabulary, or it could be even from the OCR vocabulary. So this is one of the very popular way, and there are a lot of variations people have been trying to do that. So some of the research directions that we are trying to do here is that how do you use the question to guide the answer. So like if you know the question a prior, right? You know the question because and the image a prior. So suppose I know the question, then my answer space could be very limited. So if my question is about the speed, then I don't have to predict from a larger vocabulary, right? So I can actually reduce my answer space, and which will actually improve my accuracy. So this is one direction, question guided. And based on the question, even I can know that which object should I get focused to. I don't have to even take all the objects in the scene, but I can focus on a few objects because the question is about those few objects. So question guided optimization is one of the research direction that we are looking on to. And if the question is about a text in the image and the answer is about a text in the image itself, so it could be a multi-word answer, and certain text, for example, you might be wanting to know the author or a heading of a particular billboard, that how do you cluster the text so that forms a logical answer? Because it need not be always a one-word answer, it could be a multi-word answer. So how do you understand that a group of text is actually a potential candidate for an answer? So these are some of the research problems that we are trying to look into. And also, how do you use external knowledge graphs like from ConceptNet and try to give better answers for the questions for which the answers are not actually present in the scene. So these are certain directions that potential directions that we are looking onto. Yeah, thank you.
Thank you, Dr. Vishwanath. So the last presentation is by me. So I will talk about vision in the context of conversational AI. As we said, text input, text output is, say, in a text form. Where is the role for vision, right? So, but I mean, when we think about it from a human-human communication point of view, and imagine a camera is facing, say, a user. I'm the user. I'm a interviewee, right? And there is a virtual agent, and the virtual agent is an interviewer, right? And we are interested in, say, automating interviews, right? So this is the application that we are talking about. And there is a role for vision in terms of, say, understanding my state. Say I'm a user, I'm not interested, or I'm sad, and so on, right? So there is a role for vision there. There is also a role for vision in terms of choosing the dialogue. If I'm not interested, maybe the avatar or the interviewer should say, ask, oh, why are you not interested? Rather than just asking one question after the other, right? So there is a role there to incorporate vision into the dialogue. As well as when we think about an avatar, and the avatar has to express itself, right? It has to speak something, but it also has to speak like a human, right? So in that context, I mean, you need to bring vision and graphics together, right? So that is also an interesting area of work. So as you can see, in terms of observing people, observing humans in terms of their facial expression, landmarks, where they are looking at, and so on. So there are fairly advanced open source computer vision software available now, thanks to deep learning methods and so on. So we can do very good joint estimation, body joint estimation, facial action unit estimation, head pose estimation, and so on, right? So that is done. In an interaction scenario, an avatar and a human, if you can observe humans well in terms of their body language, their speech acts, and so on, you could use that maybe to incorporate into a dialogue. So this is a very early work, 2014, where they show that you can have an interesting interaction between a virtual agent, which is animated, talking to a human, and real time you observe the humans, right? And see that if they are depressed or not happy, you change the conversation accordingly, right? And so this is broadly under the category of multimodal conversational systems, and you have analysis, dialogue, and synthesis, where in the analysis, of course, you have to recognize what the person is speaking. You also want to understand, of course, natural language, understanding what is their intent, and so on. You also want to understand the expression and affective state of the user, and maybe there is an opportunity to incorporate it into the dialogue, right? Where the dialogue problem is text input, text output. Maybe you can have some additional states based on the affective state of the user. And also, finally, you also have the avatar controlling problem, right? You have to speak a surface text, but you also have to do the gestures, you have to show the expression, and so on, right? And these can be probably learned from data, right? If you have human-human interaction data, maybe there is a possibility of learning how to express and so on. Right? So we did build a platform called Margadashi, where we have a UPSC interview that happens, 5 people interviewing a candidate interviewee there. And here we have a real system that left the lab and it is in the field where an academy is using it to do mock interview training for people. So this is something that has come out of the lab. We have also worked on, as I said, if you could incorporate the affective state into the dialogue. For example, if you have a follow-up question asking system, right, where if you have training data, question, response, and follow-up question as a training data, you can learn a model, you can predict what could be a follow-up question. So this makes the, let's say, the interaction experience more richer. Say, suppose the candidate answers something, you would like to ask a follow-up question, right? And apart from just the follow-up question generation, text generation problem, we could also additionally add the affective state into the picture. So we had some data set where we had pairs of affective state. If somebody is in a happy state, so how do you respond? If somebody is in an angry state, how do you respond, right? So we could also come up with a follow-up affective state as well, right? So we could incorporate the affective state also into the dialogue, and the dialogue turns suitably, right? And in a generative fashion. Right. And then this is some work which we have been doing on sign language, where we want to transfer from video, we want to transfer say a particular gesture onto an avatar. And for this, joint locations can be easily estimated using OpenPose, but you also have to turn it into 3D, let's say quaternions and stuff. So that you could map it onto an avatar and then do the same action on the avatar, right? So this is a work we did on 3D post lifting in a sign language context, which is very useful, because if you have videos of people signing different signers, now thanks to this you could probably transfer it all to an avatar and then use one avatar to do the sign and so on, right? And similarly, one could start looking at expressions as well, right, to transfer expression from video to an avatar and so on. And this also leads us to what is called a data-driven nonverbal behavior generation. Nonverbal behavior generation is usually, rule-based and stuff. Suppose you have a surface text for which you want to generate a suitable nonverbal behavior. You understand the POS tagging and then assign, okay, maybe gaze away or what you need to do at every say a word level, right? So this used to be rule-based, and then it got a little sophisticated and so on. Here you can see they use what is called ideation unit and so on. So what we are interested in, I think, which is an interesting work, is what is called end-to-end nonverbal behavior generation, where you have an avatar, and maybe if you can control the avatar, you can learn from data what sort of gestures the avatar should do, right? And this is what is called the gesticulator. So while speaking, what should be the nonverbal behavior? And similarly, there is also a line of work while listening, what should be the nonverbal behavior? For example, when to nod, when to do a head shake, and so on, right? So this is also another interesting area, which is a happening area in computer vision. And apart from this, apart from, say, using just the avatar as a way to synthesize, we could also use GANs, right? So there is this image disentanglement problem where, given a face image, for example, can you just switch variables, change the age, change the smile, and so on. So this is using GANs to generate, but maybe you want to manipulate in the attribute space, right? And we have tried to apply it in a form where, in the interviewing context, we wanted to create some, say, new videos which are doing, where we see that certain actions can be transferred onto somebody else. So you keep the actor there, he is doing something, but then we need to have, say, somebody else, say, where you have the source image, who are, say, your actors in the lab. Few few people who are participating, you want to transfer it onto them, and then use it for some controlled behavior studies, right? Psychology is all about controlled behavior studies. So we try to use this deep fake, which is has a very, bad name in some sense, but then here we have a very good use case for it to do some controlled studies. And I just wanted to point out that apart from having, say, an avatar to do conversation, I think it's a matter of time where we'll be talking about using GANs also for a conversational partner and so on, right? So I'll stop here, and I think the floor is now open for questions. And I mean, we have several speakers, several interesting topics. So maybe if somebody would like to ask a specific question to somebody, maybe we can take it up. Yeah, and also any general question as well. Yeah, thank you. Shall we turn it? Yeah. Okay.
No, just change.
Hello. It's a general question. I'm not sure whether relevant or not, but let me ask it. In communication channel, I come with network background. And we know if I don't want to talk, we have a jammers, that nobody can talk cell phone something. In this conference, I don't want anybody to have a cell phone record the whole thing. Are there video jammers available so that you can prevent no recording can happen, even though visually we can see that? If anything, what kind of technology are available? Anybody?
See, you know, what is the jammer for, because you are looking at actually physical event and you being there, right? So just like the equivalent of jammer here would be to turn off all the lights, okay? So if you do turn off the lights, then there is nothing, because finally if you look at the optics of the scene, right? So light comes in, gets reflected, and that gets what you get the image. So as long as the light reflection would be there, right, I cannot prevent that, okay? So what you see is your lens is nothing but the corresponding the lens in your eye, and you have a retina is basically the film. So if you can record, if you can see something, by definition it has to be there, right? There's no, I don't think there is any other way. Yeah. There's one more there, Mike. One more.
Sir, you talked about fairness of data. So firstly, what do you mean by fairness of data?
So fairness of data, I mean, there is a proper, I think if you look at a FDA documentation, they have even given a guideline of what they mean by fairness of data, and it probably encompasses a lot of things, right from the collection to processing to training to everything. So it can mean multiple things in multiple contexts. So you have to collect properly, and then you have to have your training it to be in an unbiased manner. A lot of things, like if you are going to use transfer learning or any other pre-trained model, is it? So it can mean a lot of things. So my answer is vague, but because this is vague, but for a very good guidance, I would suggest to look at the FDA's guiding principles. I don't think they are directive principles. They are sort of a guiding principle. So probably that would be a better way. So at a very simple level, it's like don't go biased towards any population. For example, don't go in the US, North America, Caucasian population and try to apply that in our. For example, in brain volumetry, probably experts are there. People would know that Korean brain may be slightly smaller than an Indian brain, smaller than a. So if you apply Alzheimer's disease brain volumetry and try to take some ratios of Caucasians, it's not going to work here. As a small side example.
Question regarding lip reading. So lip reading, if you have a video of somebody who's talking without any audio feed, is it possible, what's the current state of art in being able to decode the speech from the movement of the lips and the facial muscles? Implications of this is, for instance, if there are deaf people who are watching. Okay, is it possible? Yeah, is it possible to automatically convert that speech because it's a known context?
Haven't followed the recent literature on I mean, there has been works I've seen, but haven't followed the recent literature. I mean, whether if there is any update or improvement in performance. It used to be a hard problem. I think it is not an easy problem.
Is it still an open problem or is it a solved problem?
I don't think it is solved. I think it is still an open problem because it's not easy. But I think with new cameras and maybe newer way of imaging, I think it could have gotten better. But sorry, I do not know the latest numbers in some sense. Yeah.
You could. Yeah.
See, there's if you say lip reading, in some sense, like I open whatever it is and then you go back, I would say 20 years ago, when you do the animation, let's say supposing, I wanted to animate an avatar the other way, in a forward process, then actually there is something called FFE, facial action parameters, right? Because in MPEG and others, MPEG 7, I think they have some of these things, right? So then actually even we did some work where you said you can use that so that it's a lip is syncing, because I have a conversation, so whatever we do, it should be some lip sync should happen. Now, of course, there are a lot of work on that, and I think people can do a lot better because of the deep learning. What you are saying is the opposite, okay, the inverse problem. So now you are saying that. Now, given that if you can do training, okay, it's in some sense the immediate answer probably would be say, oh, we trained so many interesting things. Why is it going to be that difficult? Okay. Then, if you look at a ventriloquist, okay, now go back to that. So naturally, they will defeat that. I mean, that's his adversarial thing. If you can do that, I mean, they talk, like, all these things. So that means there could be multiple solutions for that which will try to do it. So you may get something, but there may not be any uniqueness. That's what probably do. And I think maybe Vishwanathan would be the right thing, person. That when you convert, see, the problem would be now, it's a one-dimensional sequence, but it has a syntax and the meaning. So what you generate, that the corresponding, the learning, it has to have a meaningful, the syntax, and following that may not be possible, so or may not be that easy. I don't know whether, I think
yeah, the signal is going to be very
noisy, and then maybe, you can get bits and pieces of words, but that may not make a complete sentence. You want to add anything?
So this technology of pure understanding of what is being spoken from lip reading, whatever exposure I have in Samsung, it's a very difficult task to do. But we don't try to solve just for lip reading. For example, if you are giving a command in a very noisy scenario, like you are traveling outside in a bus and you might want to interact with your phone, like using a verbal voice command, then many times the voice itself will be noisy, right? So you use it as an augmented technology to augment the voice command. So understand both from as well as from the voice as well as from the vision, and then get the right command. So as an augmenting technology, there's a lot of interest in it, but not as a pure technology that can fully decipher what you have spoken. Yeah, so the specific. Yeah, so exactly, I'm coming to that. Limited vocabulary when we are trying to solve for Bixby voice commands. So the voice commands in Bixby are a set of voice commands. So from that, what the person is trying to speak, that's more doable because it's from a predefined vocabulary. Yeah.
I had a question on the way this technology is being abused. We've got deep fakes now. So do you think the answer to that, one of the answers today is extra vigilance. People are doing fact checks. But is there a technological solution to deep fakes? Because deep fakes are now being used to mold public opinion.
Okay. Yeah, deep fakes are like kind of adversarially attacked images or videos, right? So yeah, still we don't have any reasonable technology to detect them, whether it is fake or real, right? Because whenever you try to create algorithm, you can always attack that algorithm and then overpower the algorithm and create a new deep fake, okay? So it is like an adversarial situation, right? So it's like a game played by two parties. One is created by deep fake, another is by those who want to find out what is deepfake, right? So both are technologically gaining each other, and then I don't see, but fakes are so powerful, it's very difficult to find out whether it is really a fake image or not. Even if I create an algorithm, I can always attack the algorithm and fool the algorithm. So that's why it's difficult.
See, I mean, if we concentrate on the visual aspects, if you do it in a natural setting outside, okay, in some, your machine learning may not be able to do it, but the human can do it, okay. And the reason is from the context. See, normally what happened is that when you try to do it, I tell you in one particular case, okay, I went to a place and then we find a very well-known picture of something, of a person, okay, which is old, like this thing. And I saw it's a colored and very nicely done, okay. Then I asked, like, what is, and it was an outdoor setting. Then they said, oh, it was somebody, did it from somewhere else. I said, this is, I can see that this is wrong, okay. And he says, how do you say that, okay. I said that, then you look at actually the composition aspect of this. What I found that actually, when they tried to merge two things there, the shadows, if you look at the sun as outside, the shadow directions are different, right? Similarly, so this is like a clear thing which probably a machine learning, unless it is specifically trained, will not do it, okay? But you as an individual, if you really look at the careful, okay, you may be able to do it, okay. On the other hand, similarly, once I saw somebody created, actually, this is like a special, your visual special effects. They're creating a Second World War kind of scenario where the fighter thinks that Spitfires are going and they're dropping bomb, right? So everybody said it's nice, okay. I said, no, there is something wrong, I can see it, okay. So I said, when you drop, it looks all fine, but the physics is being bullied here. This is, what is it? He says, when I start from the bomb from there, because today's thing is a missile you fire, but over there you just drop the bomb, okay. That was those days, Second World War, right? So the gravity means you start with the acceleration, right? So the speed would go up, and it is going at a constant speed, right? So, I mean, see, you have to be beyond this. I mean, I don't know, maybe someday machine learning can pick up, but as of now, I think we can do a much better job if you just say that this is whether it's a fake or not, okay?
So another point here is that, if you see these deep generative models, I mean, over the time, it's very strong now, right? So if you see style transfer and all this kind of problems, so these are like extremely powerful. And in this deepfake, I would say that if you see the paintings of different artists, okay, so now there are actually companies who can give you a like very well-known painting, right? And it's very difficult to differentiate them. And I would say the deep generative models, GAN and all this stuff, they have become extremely powerful. I mean, many things come up in the training and all this thing. So that's why it's rather difficult to, you know, unless you look very minutely, it's very difficult. And the other thing is that this is many to many problem, right? So there could be many possibilities, right? So it's very difficult to constrain them also. Yeah.
This question is for any of you. I mean, how do you de-hijack computer vision from ML?
I think you are the right person.
The question is de-hijacking? Okay. Okay. Yeah, our lab's name is Video Analytics Lab. Currently, we are not doing anything with the videos now. So, with deep advancement, actually, we actually moved slowly from vision to actually ML now. So, most of the problems that we are attacking in our lab is mostly the ML problems, but the input that is given as the data is just the images or videos. So it is all about kind of how will you do domain adaptation, how will you create adversarial attacks, or how will you make your model robust. Except the input, it is very generic. It can be used across various domains. So I think ML has penetrated almost all the application fields like vision, NLP and speech, all those things. So if you want to remove deep from all these things, then basically we are going back some 15 years or so. And there is no data available and no compute power available. So basically, I don't know why we want to go back in time when we can go forward in time and do better with time. So
I'm going to ask a question to Venkatesh Babu only. So, I mean, you said in your presentation, right, the robust models, if you go towards robust models, it's like almost, it's like puncture, right? I mean, you puncture a, so, I mean, still you want to work in deep learning.
So initially, yeah, basically we are fascinated by CNNs and its performance. And somebody came all the way and then told, oh, this is just a foolish network. Then we are all shocked initially. Then we thought, oh, such a big model can be fooled. So then it's a kind of created a curiosity to kind of why can't we attack the system, okay? And then try to attack. First, initial our works were all about attacking the deep models. Unless you attack the model, you cannot make the model robust. So you should be a big attacker, you should be a big hacker to become an expert in that field, right? So you should expect what kind of attacks that can be done, the sophisticated attack, then probably you can try to protect your net. So our this thing always started with the attack. We became an expert attacker, then probably we transformed into a defender, basically. Unless you have the best attack, you cannot defend your system, right? So the major problem that we face in adversarial thing is the evaluation. Even you can train a model, adversarial model, but the evaluation is very, very tricky because there are thousands of attacks available. You have to escape all the 1,000 attacks to prove yourself correct. So it takes a longer time to evaluate your robustness of the model, where we spend huge amount of compute power and days together for each experiments, and then say, okay, we are really robust. If you are not doing that, you are just cheating the system. That's what I would say. So unless you know how to attack give sophisticated attack, you are not going to defend your system. So it is not against deep, it is to make your deep model better. That's what we are working towards, okay?
Maybe I can make a philosophical comment, I think, on this one, all right? See, if you look at the evolution of science as of such, okay, right now we call it fourth paradigm of science, okay? So at the beginning, okay, it was more like observational. If you look at, you observe, and then you come up with something like, okay, maybe buoyancy, okay, you look at Galileo, other things. Then afterwards what happens is that you move it into a nice theoretical framework that you put in there, okay. So everything, like, you try to see that there was like a Renaissance time, there was a lot of such thing that happened. So you have come up with formalizing a certain kind of physical process, okay. Then what happened, the third, so that was the second one. The third that happens, okay. And by the way, each was trying to actually then validate with respect to the previous thing. Then you go to the third one, which is actually on the simulations and the model, right? You different kind of, you simulate this on the computers and others and see that you run it before you actually do that. And then of course you know, if you know the physics and others, whatever the thing, you try to see whether it validating with that. In the fourth, what happens? Now we are right now, it's a data driven process. So you have a data, you have an input output, okay, and you wanted to see that I can somehow relate it with some kind of a. Now what is missing in that, as yet it has not come, is the physics engine, okay. So you have to now go back and use the physics part of it, right. So when that happens, then automatically this thing would now bootstrap. See, it's a great thing that we are using data science. There are a lot of advantages of using it because it gives you a lot of flexibility, large scale modeling. But once you put the physics also inside it, right, then I think you will see the big boost, and many of these problems that we are talking about, probably some of them will be, I'm sure, will be taken care of.
So just one thing I need to add here. So I mean, we are all in deep learning talk about the recognition problem, right? But I mean, code vision problem is more of a structure prediction, right? So there, like if you see this depth estimation or optical flow, this kind of problem. So of course there's a learning part out there that we cannot ignore the data. But if you see the regularization of it, so the consistency and all the regularization, that comes from the vision part, right? So I won't say like to solve vision problem, we are just ignoring the vision part. So the data, of course the data is giving you much boost, but the actual constraints that are we are using from the vision phenomenon. I would say that this is a combination of both. The data is actually helping out together with the concept that we had in the vision point of view.
You had a
So any learning is based on historical data, right? I mean, we need historical data to do any algorithm. I would like to hear one or two examples to relate what is the size, volume of the historical data you need for better result, one. And if we increase that horizon, do we improve the performance of the algorithms? One example I can give here is, let's say, I also work in security area. So let's say there is a person or different persons loitering around outside my area, outside my boundary wall, doing no harm, but I can see a pattern in loitering visually. Can I codify it and find out what could be the behavior? Is the same person? Is the same pattern? Is it an attack impending on me, etc., etc. So
there are two parts actually. One is more data, does it help in learning? Yes, definitely it is. So if you look at Google, they have a huge amount of data. So whenever they present the result, they simply write one line. We pre-trained our model on our internal data set, which is nothing but 300 million images, okay, which we have no access to. So of course those models are going to perform much, much better than whatever we do at academic level, right? So more data is better, not only for training as well as for adversarial training also. You can make your model more robust by adding huge amount of data. For example, if you pump 100 million images, additionally you get some 78% improvement in your adversarial performance. Yes, you get it. And the second part is actually loitering about this thing. This sounds like an anomaly detection problem to me. So you have a camera, you keep watching the person coming every day and doing something. So you have pattern, right? So you can code the pattern actually. You can learn the model based on his pattern, right? Yeah, kind of. For example, you are observing for 1 month or 2 months time, okay? And probably you have a model ready. Now you feed your input to the model and then see whether it fits the pattern or not. If it is not fitting the pattern, then something is wrong going on. So that is how we can decode whether the person is actually doing something new or is it a usual activity, right? So because you don't create anomaly, examples are not available, so this is the only way you can find out abnormalities.
Supplementary of this would be, so are we hitting that constraint of processing and memory issues? How does, for example, Google manage 300 million images? Because they are using distributed computing. In our work, in our labs, are we hitting that sharing of power and compute power?
Yes, yeah. See, now the new problem that we started with the deep models, especially when you are talking about transformers, you can see most of the transformer papers, they are coming out of Google, Facebook, these kind of people. Because training a transformer in an academic institute is not an easy task. It takes much more compute power than CNNs. And they have huge amount of data because we only give the data to Google and they have annotated data. Whatever we do in the academic community for about a month or so, they can do it in a few hours, right? So they have a huge advantage in terms of creating a model, sweeping the entire parameter and getting the best results. It takes almost few months to go to that particular, get the result from sitting at academic institute, where we severely restricted by compute power as well as the data, right? So this created a huge division between the corporate research and academic. Yeah, that becomes because of the data-driven scenario. Because more data, you are big, richer guy, right? Lesser data, yeah, you are poor guy. So that's how none of the corporate guys release any data because that's their private proprietary thing. So they won't disclose this because they have paid huge amount of money to create this kind of data. So they will never ever release the data publicly, right? So that is their strength, okay, because they are into business. Whereas we are open kind of, we wanted to do everything in an open research domain. So where we lack data, where we lack compute power. So with that, it's very difficult to compete with corporate research at this point of time, especially when data-driven approaches.
You know, but one comment is that it's not necessarily only in the machine learning. So this is true for almost now. The modern science is extremely resource oriented, okay? And if it is biology, if you take it, if it is chemistry, all these equipments are extremely expensive. See, even I tell you what IISc or IIT Bombay or some of the things can do, some of the other colleges simply cannot do it. So because, you know, it needs those kind of things which is not possible, right? So and that's why just like in this case, I think the data is the king. Here also, if you have one of these fancy machines, then you can do a lot more advanced research than if you don't have, you can't do anything. You know, it's as simple as that. Okay.
Sir, is there any specific research going on? Say, for example, I'll just take a name, what we have called as click in graph theory. Is there any research going on in your perception or in your view where the quantum computing has certain click-based analysis? Suppose there is a quantum of data, but I am interested in certain clicks, and machine learning or mathematical models focusing on the analysis of those clicks.
I'm not aware of.
I think the one, I don't know what is your definition of click. Click has been used in, classically. If you look at Markov random field, or if you look at, Ising models and all, is basically the relationship between two lattice points. That's actually the click. And this is how it is defined. Is that what you're talking about?
Yeah, so now the ideology is same. The let us say template remains same of the ideology. Now same thing gets applied to the quantum for a specific subset of the quantum.
No, so what is the point? I mean, the question in that sense. Maybe
so the question is, suppose I have a quantum of data. Suppose it's in terabytes and terabytes. So out of that, I want to set up certain click between the meaningful data and define the click-based templates in the quantum. And then in that click specifically, we will apply machine learning. Because
So
I am not interested in
okay,
entire
so I
quantum.
mean, I've not fully understood the problem, but the thing is, you were saying that you don't want the data to be, some kind of a random access. You want it to be some neighborhood or something in which you want to process. So if you ask somebody in a computer science and other people, like normally earlier classical days that used to have some linked list and all, you would have followed to see who is neighbor of what, how do you go, how do you travel through this. Because any system, if you look at your computer, even the way you store, neighboring data doesn't mean your neighboring your point. It could be anywhere on the system. You don't know. There is a table that might, so here I don't know, because you are talking about physically being close. So that, in the computer space, it doesn't have to be.
It's a logical. Say we have a click in graph theory. So out of the complete, say, whole graph, we have certain 3-point graph as a one click. So in the, say, 20 terabytes of quantum data, I would say one click is 1 terabyte of certain type, and another is, say, 100 GB, another is 20 GB. So between these three, I want to do certain mathematical modeling specific to that.
I'm not sure I understood unless somebody has, but I think that typically if you look into the graph theory, they also, the click is basically what they are again connected. And actually if you have a fixed graph, then for all kind of a problem, then there are graph Laplacians and others which can actually help you to do that. If that is the question, then you should look into that aspect. But if you relate to some quantum computing that I am not, I don't think I understand the problem.
So basically, if you see the Laplacian, so L raised to k is the kth hop, right? So in this way, you can see how the nodes interact. And coming to, say, graph convolution network something, and one of the ways is to do that something called spatial graph convolution, okay, where you see if there is one layer, a node is connected to the neighboring node. If it is two layered, so first node and second node. In this way, you can actually propagate the message passing and all this kind of thing you can do there. Might be that could be a partial solution to what you say, but I'm not, of course, I don't know what.
Because majority, I'll tell you the reality. And even in the industry, I'm from industry. So what is the reality, sir? The machine learning based all the statistical alignment, what has been done, statistical algorithms transformed into ML algorithms with certain enhancements. So they have certain what we call as the boundary value restrictions. Those algorithms directly cannot be applied on quantum data. So now the challenge is that when I have terabytes and terabytes of quantum data, I need to generate certain clicks of the patterns, and then those, even the machine learning standard formulae need to be put into a second stage derivative formula so that those clicks could be analyzed in the context of the business application. Yeah.
This is more of a quantum machine learning.
Yeah.
Because you are talking about is a large data that you don't want to fetch the entire data set onto your RAM or whatever you are doing.
Yeah.
So there will be like page thrashing, all those things will keep on happening. So probably you are looking at points. What is the efficient way of collecting data from there, bringing it to your local system, process it, and then by the time gets the next data set. I think this is, I think some classical computer science problem. I think, if you ask somebody, I think maybe they would be more comfortable in. But this is a difficult thing when you go for terabytes of data. What would be the design philosophy? It's definitely a problem. But I think now I understand your problem.
I think we have Professor Subhashish and Biplab needing to catch a flight and so on. So in the interest of time, thank you. Thank you, audience. It was great questions, and thank you all panelists. It was a great discussion. I think initially I was not sure how it will turn out and stuff, but I think there was a very rich set of interesting, diverse problems showing the diversity of the field, computer vision, and still philosophical questions. I mean, is the deep learning the right way, or maybe we need physics-based models, and a wonderful discussion. So thank you, everyone. And I give the floor to.
Thank you, sir. So floor is yours only. Please honor our panelists with a little memento from ACCS.
as well.
Yeah. I request Dr. Srinidhi to give a memento to Professor Dinesh. So I hope we had a wonderful day, short yet very engaging, good discussion. Thank you very much, sir, for coming down from Mumbai. You too, sir. I think we have had a great day today. If you all agree, give a big round of applause. And thank you very much.